The story begins not with light, but with shadow. Across the black canvas of interstellar night, far beyond the gentle pull of our sun, a fragment of the unknown hurtled forward. It bore no herald, no trail of fire like a comet, no steady glow like a star. Instead, it moved in silence, its presence betrayed only by the faintest whisper of reflected light captured by careful eyes. Astronomers would give it a name 3I, Atlas, but long before human beings turned their lenses toward it, the object had already traveled for millions, perhaps billions, of years through the desolate corridors of the Milky Way. The announcement of its detection carried a tone that was both clinical and trembling with awe. Another interstellar visitor. Humanity had seen one before, Oumuamua, and then a second, Borisov. But this one seemed stranger still, a ghost born from distances so unfathomable that even language falters in its attempt to describe them. Its discovery was more than the cataloguing of a wandering rock. It was a reminder that the void between stars is not empty. Hidden in that darkness are relics, fragments of shattered systems, cold witnesses to the violence and unpredictability of cosmic creation. The first images, rendered in grainy pixels, offered little detail, only a tiny smear of light against infinity. Yet, within that smear, the human imagination stirred restlessly. What was this body made of? Ice? Rock? Metal? Had it once belonged to a planetary system like ours, circling an alien sun before some violent gravitational dance flung it into exile? Or was it something stranger, an object sculpted by forces unknown, or perhaps even the remnants of an intelligence that predated us by aeons? The scientific mind is trained to ask carefully, to test, to doubt, and yet, in the quiet corners of observatories, behind the discipline of equations, there was a murmur of unease. This interstellar wanderer was not like the countless asteroids catalogued in the solar system. It had no predictable ancestry, no familiar orbit. It had arrived uninvited, bearing with it the possibility of revelation or ruin. For interstellar objects remind us of a truth both comforting and terrifying. The universe is vast, restless, and indifferent to the fragile lives that briefly open their eyes upon its stage. What startled astronomers most was its trajectory. Not bound to the sun, not obeying the eternal rhythm of elliptical orbits, it traced a hyperbolic path, evidence that it came from elsewhere and would, in time, return to elsewhere. And yet, even a path defined as passing through carries with it the weight of uncertainty. A few small deviations, a whisper of gravitational tug, and its voyage might intersect with Earth's. Probability was low, but not zero. And in the long arithmetic of existence, even the smallest chance can become a haunting. Thus began the story of 3I. Atlas, not merely as an astronomical curiosity, but as a mirror held up to humanity's fear of the unknown. It asked us to consider what it means to live on a small, vulnerable planet, adrift in a universe that occasionally throws stones across immeasurable distances. Each detection, each measurement, each calculation brought us closer to confronting the worst-case scenario. And like the tightening drumbeat of a film score, the first appearance of this object was only the overture to a story of science, speculation, and the shadows cast by our own imagination. It was on a night like any other for astronomers, when the hum of observatories echoed with routine vigilance, that the first whispers of 3I, Atlas, came into focus. High atop a mountain where the air thinned and the stars gleamed with ferocious clarity, the asteroid terrestrial impact last alert system Atlas fulfilled its patient duty. Designed to watch for objects that might one day threaten Earth, it scanned the heavens in quiet arcs, sweeping the sky with unblinking electronic eyes. On that night, Atlas noticed something faint, something that did not fit the familiar rhythm of near-Earth asteroids or long-period comets. A subtle point of light, was shifting faster than it should, its trail stretching across exposures in a way that told of remarkable velocity. The data was flagged, double-checked, and then shared with astronomers across the world. Almost immediately, the whisper of discovery spread into an electric current of curiosity. At first, it seemed fragile, too faint perhaps to be of consequence. But as additional telescopes were directed toward it, the motion revealed itself with growing certainty. This was no ordinary wanderer of the solar system. Its course was steep, its angle sharp, its speed astonishing. Unlike the closed ellipses that govern the paths of asteroids and comets, its orbit was hyperbolic, a curve that spelled one undeniable truth: it had come from interstellar space, and unless something extraordinary intervened, it would return there again. The night of discovery transformed into days of urgency. Astronomers scrambled for more observations, racing against time, for such objects move swiftly, and once they fade into the glare of the sun or drift beyond the reach of our instruments, they are gone forever. Every second of telescope time became precious, every measurement a fragment of a story that had to be assembled before the cosmic messenger departed. In Hawaii, in Chile, across Europe and Asia, observatories trained their lenses on this faint interloper. Scientists spoke of it in hurried calls and late-night emails, excitement tempered by the weight of protocol. They had seen such things before, or so they thought. Oumuamua, the first known interstellar object, had swept through the solar system in 2017 like a sliver of memory from another world. Later, Borisov followed, a comet that wore its icy nature proudly, its tail gleaming with familiar chemistry. But 3I, Atlas, was different. Its brightness rose more quickly than expected, as though something volatile was stirring within it. Its path cut sharper angles than its predecessors, carving through the solar system like a scar etched across a vast canvas. In scientific circles, voices lowered when they spoke of trajectories, for the numbers carried an uneasy undertone. Although unlikely, there lingered a chance, however remote, that the path of this cosmic wanderer might intersect with our own fragile world. The night skies became stages for silent drama. Amateur astronomers joined the hunt, capturing images with backyard telescopes, adding their pixels to the global effort. The object glowed dimly in their frames, a smudge against eternity. Yet each smudge carried profound meaning. Humanity was not alone in its celestial neighborhood. The galaxy itself had sent another fragment of its hidden depths to brush past our doorstep. The initial discovery reports, dry in tone but alive with implication, marked the beginning of something greater. Each notation magnitude, arc, velocity, was a doorway into speculation. Was this a shard of a shattered world, flung from its home star by gravitational violence? Was it a piece of cosmic debris wandering aimlessly for millions of years until fate guided it here? Or could it be something even more unsettling, a stranger in our skies carrying mysteries beyond material composition? In the stillness of observatories and the glow of computer screens, the first notes of fear and fascination blended. Humanity had witnessed the birth of a new chapter in its cosmic awareness, one that began not with a thunderclap, but with a faint flicker against the velvet of night. The discovery was official. 3I, Atlas, had entered the solar system, and with it, the ancient dread returned that the stars do not always send gifts of wonder, but sometimes messengers of peril. The deeper astronomers gazed into the numbers, the more unsettling the truth became. The orbit of 3I, Atlas, did not meander like a lost comet, nor did it fall into the familiar dance of elliptical return. It cut across the solar system with uncompromising intent, racing on a hyperbolic arc that revealed two facts at once. It was not of this sun, and it moved faster than almost anything we had catalogued before. To call it fast was to understate the reality. Its velocity exceeded the quiet drifts of asteroids, surpassing the gentle accelerations of long-period comets. It was moving with the reckless freedom of a traveler unbound, immune to capture, indifferent to the sun's gravity, save for a brief bending of its course. That bending, though, was precisely where fear began to whisper. For a hyperbolic path is not a perfect abstraction. Slight deviations, nudged by the pull of planets or the invisible hand of radiation pressure, could alter its destination. As computers rendered orbital projections, a troubling picture emerged. Dozens, then hundreds of simulated paths spilled across digital skies, like threads of fate unfurling from a single point. The majority bypassed Earth by comfortable distances, but a small fraction did not. In those threads, the blue marble of our home lay squarely in the object's potential path. Probability was low, vanishingly low compared to the certainty of safety, yet the cosmos does not negotiate in terms of comfort. To know that a stone from another star system could, in principle, strike the Earth was enough to awaken an unease that scientists rarely voiced aloud. The unsettling speed compounded the dread. At such velocities, even modest mass becomes catastrophic. A fragment only 100 meters across could release energies rivaling thousands of nuclear detonations, turning cities into ash and skies into storms of fire. If larger kilometers across, it could end not merely civilizations but ecosystems, leaving behind a scar that would echo for ages. To imagine such devastation, carried silently from another sun's catastrophe, was to confront humanity's fragility with unnerving clarity. The very trajectory was an insult to our assumptions. For centuries, celestial mechanics had offered a sense of order: Kepler's ellipses, Newton's laws, Einstein's curvatures. Yet here was a body that obeyed those laws while still mocking our security. It was proof that the sky's serenity was an illusion, that the fabric of the heavens is not a stable dome but a restless ocean, occasionally sending rogue waves to crash against our fragile shore. Publicly, most astronomers calmed speculation, emphasizing the improbability of impact. Privately, some wrestled with sleepless nights. The discomfort was not only statistical, it was philosophical, for this object reminded humanity that it does not sit at the center of a safe, predictable cosmos. It is instead a tenant of chance, living in a universe that throws dice across millions of years and billions of kilometers. The object's speed also made observation difficult. Unlike the stately comets whose tails linger for weeks in the sky, 3I Atlas was fleeting, racing beyond grasp, even as it was first noticed. Days mattered, sometimes hours, for in that small window humanity had to decide how much of its fate was knowable. Telescopes swiveled, radars hummed, satellites turned their sensors outward. The hunt was not only for data, but for reassurance. To measure was to hold the illusion of control. To fail was to surrender to cosmic indifference. In its path and velocity, 3I, Atlas reminded us of another truth, that the universe is not only beautiful but also dangerous, a place where vast forces operate without intent, and where survival may hinge on the faint chance of distance. Its speed was not a curiosity, but a symbol of the relentless energy of creation and destruction that shaped galaxies, stars, and worlds. Humanity, small and brief, was once again forced to consider its place in this drama. And so, the strange visitor moved on, an interstellar shard slicing through our system with indifference. It obeyed no human story, no terrestrial fear. Yet, in the quiet of observatories and the growing hum of speculation, its speed became more than numbers. It became a question carved into the darkness. What happens when the unbound chooses to pass too close? The appearance of 3I Atlas inevitably summoned memories of another wanderer, Oumuamua. In 2017, the astronomical world was shaken by the sudden revelation of that elongated object, tumbling end over end as it sliced past the Sunday. It was the first confirmed interstellar visitor, a messenger from another star system, and its passage ignited debates that continue to this day. Its strange acceleration, its cigar-like shape, its silence where a comet's tail should have been, all of it combined into an enigma that refused to be neatly categorized. Some whispered of natural origins, others of artificial sails, and the arguments spilled beyond journals into the imaginations of millions. When Atlas revealed its third interstellar object, comparisons to Oumuamua surfaced immediately. Could this be another strange shard, another sliver of alien history? Or worse, would it defy explanation in ways that even the first two had not? The parallels unsettled the scientific community. For Oumuamua had shown us that interstellar objects exist in numbers we had not predicted, crossing the solar system with unnerving frequency. If 3I, Atlas, carried with it the same anomalies or new ones, it would mean that the cosmos was far more chaotic than the orderly models we had clung to. Scientists recalled the fever of speculation that followed Oumuamua. Papers were published in rapid succession, hypotheses multiplied like sparks. Hydrogen icebergs, nitrogen shards from Pluto-like worlds, debris from shattered planets, even probes built by distant civilizations, all were entertained, none proven. The uncertainty itself became the lesson. If one visitor could upend so many assumptions, what might the third one do? Would it confirm suspicions or plunge us deeper into doubt? The echo of Borisov, the second interstellar object, was also remembered. Unlike Oumuamua, Borisov behaved more like a traditional comet, outgassing, brightening, trailing a dusty tail. It was a reminder that not all interstellar travelers are anomalies. Yet even Borisov's chemistry held subtle peculiarities, whispers of an origin under alien suns. With 3I, Atlas, humanity faced the unsettling possibility that each visitor might be unique, a fragment of a different stellar system, a piece of a cosmic mosaic too vast to comprehend. The memory of Oumuamua colored every observation. When Atlas brightened unexpectedly, astronomers wondered if the same mysterious accelerations were at play. When its trajectory defied easy prediction, they recalled how the first object had left us grasping for explanations. It was as if the universe had sent a trilogy of riddles, each more complex than the last, daring us to admit how little we understand about the interstellar sea through which our solar system drifts. But beyond scientific curiosity, there was another, darker memory. Oumuamua had awakened not just wonder, but fear, the realization that objects from beyond could arrive without warning, unseen until they were already upon us. If such a body had been on a collision course, humanity would have been powerless. That helplessness still lingered in the minds of astronomers, a shadow that stretched now across the new detection. With Atlas, the shadow seemed to lengthen. The comparisons were unavoidable, yet they also carried a dangerous implication that we should expect the unexpected. If one interstellar visitor looked like a comet, and another like a shard of metal, and another like something else entirely, then there was no pattern to rely upon, no safety in prediction. The galaxy might be filled with countless such fragments, each carrying the potential to challenge our science or threaten our survival. In the quiet after the initial data rush, when the skies darkened and observatories waited for their turn under the stars, many astronomers found themselves haunted by memory. Oumuamua had shown us that interstellar objects are real. Borisov had shown us they could resemble what we already know. But Atlas was different. In its light, its speed, its sudden emergence, there flickered the suggestion that the story was only beginning, and that the worst-case scenario was not mere imagination, but a possibility we must confront. At first, the tone was celebratory. The announcement of 3I, Atlas, spread quickly through the community of astronomers, rippling outward into press releases, late-night phone calls, and urgent requests for telescope time. It was rare enough to find an interstellar visitor once in a lifetime. Now, humanity stood before its third such encounter. The excitement was palpable, tinged with the exhilaration of discovery. A new piece of the cosmos had wandered into reach, and scientists were eager to seize every possible fragment of data before it vanished again into the dark. But alongside that thrill came a growing unease. The object's brightness was rising faster than expected. Some whispered that it might be disintegrating, shedding material in a way that did not align with familiar cometary behavior. Others noted the strange inconsistencies in its trajectory, the margins of error that refused to narrow as neatly as they should. To the seasoned eye, these were not the comforting signs of a well-behaved celestial body. They were reminders of how little could be assumed. Astronomers are trained skeptics, bound by the discipline of measurement. Yet even they are human. In the quiet pauses between calculations, in the moments when telescopes shifted and data compiled, there lingered an edge of dread. Because what made Atlas extraordinary was not only its origin, but its unpredictability. Interstellar objects move at such speeds that a single miscalculation can cascade into startling differences in their projected paths. The smallest uncertainties widened into existential questions. Meanwhile, the race for data intensified. Telescopes from Chile's deserts to Hawaii's volcanic peaks swept the object nightly. Spectrographs passed its light, dissecting wavelengths to search for familiar elements. Radio dishes strained for echoes, though none were expected. The object revealed hints, but never clarity. Traces that suggested icy material, signatures that seemed cometary yet refused to behave in fully cometary ways. Each new observation fed the paradox rather than solving it. In scientific papers and private conferences, voices began to diverge. Some declared Atlas an ordinary interstellar comet, albeit one whose fragile body was crumbling under solar radiation. Others urged caution, pointing to anomalies that recalled the mystery of Oumuamua. The discussions were sharp but veiled. No one wanted to ignite public panic, yet few could ignore the strangeness. The line between curiosity and concern blurred as the days passed. What elevated the unease further was the timeline. Interstellar objects do not linger. Their windows for study are brief, sometimes only weeks. Each night, lost to cloud or technical failure, was a slice of knowledge forever denied. This urgency became a pressure, one that carried the weight of both opportunity and fear, to capture the truth before it slipped away, and to confront the implications of what that truth might be. For beyond the equations lay a sobering thought. If Atlas behaved so differently from expectations, what else might lurk unseen, waiting to emerge from the darkness? If one such object could approach, unnoticed until discovery, then countless others might have already passed, invisible or unremarked. And if among them even one carried a trajectory aligned with Earth, the consequences would be irreversible. Thus, the initial excitement gave way to something heavier. As instruments locked onto Atlas and the data piled higher, scientists found themselves not only in pursuit of knowledge, but caught in the tightening grip of uncertainty. The interstellar visitor, once a source of awe, had become a mirror for fear. It was not merely what they could see, but what they could not, what the numbers refused to settle, what the patterns refused to explain. The celebration dimmed, replaced by an urgency tinged with apprehension. Atlas had arrived, and with it came the reminder that discovery is never free of dread. With the discovery secured, the next step was scrutiny. Telescopes across the world bent their gaze toward the faint speck of light, each night peeling away another layer of mystery. The object was small, far smaller than a planet, or even most comets, yet its faint glow carried information for those who knew how to interpret it. By dispersing its light into spectra, astronomers could glimpse its hidden character, whether it reflected dull rock, volatile ice, or something more complex. At first glance, 3I, Atlas, seemed comet-like. Its brightness fluctuated as if some material was outgassing, shedding dust or vapor into the void. But unlike the familiar comets of our solar system, its behavior was irregular. No grand halo encircled it, no tail unfurled behind it with predictable grace. Instead, the signs of activity were subtle, fragmented, almost reluctant, as though the body itself were unsure whether to reveal its composition. Ground-based telescopes measured its albedo, the reflectivity of its surface. The numbers hinted at a dark object, one that absorbed more sunlight than it returned, cloaked in a mantle of ancient dust. Radar reflections proved elusive. The object was too distant, too swift. Yet even in that absence, questions multiplied. If it were rich in ice, its activity should have been stronger. If it were a bare rock, its faint glimmer should have remained steadier. Instead, it seemed to dance between categories, refusing classification. Spectrographs in Hawaii and Chile teased faint absorption lines, signatures in the light that hinted at molecules escaping the surface. Some matched water vapor. Others suggested more exotic compounds, frozen under alien suns and preserved for eons in interstellar exile. To think that a grain of dust released by Atlas might carry chemistry foreign to our solar system was to confront the possibility of sampling another star's history. Yet each clue came burdened with ambiguity. Instruments strained, signal-to-noise ratios teetered, and interpretation remained fraught. As data accumulated, the picture of Atlas became both richer and stranger. Its size was estimated at perhaps a kilometer, across large enough to carry apocalyptic energy if fate aligned its path with Earth, small enough to remain elusive in detail. Its rotation was irregular, wobbling as though damaged or asymmetric. Some computer models suggested it might be a fragment, a shard torn from a larger body in a violent event long ago. Theories spread quietly through conferences and private discussions. Perhaps Atlas was the remnant of a shattered exoplanet, flung outward by gravitational chaos. Perhaps it was an icy relic ejected during the birth of an alien solar system, carrying with it the frozen signatures of a star unlike our own. Or perhaps it was something even stranger, a body shaped not by planetary formation but by phenomena we had yet to name. The instruments kept watching. Each observation added data points to the growing archive, yet clarity remained distant. The object revealed just enough to demand deeper study, but never enough to yield to certainty. It became, in essence, a paradox in motion, simultaneously familiar and alien, both comet and not comet, a messenger whose message remained shrouded in ambiguity. And all the while, the clock ticked. Every passing night brought Atlas closer to the sun's glare, where observations would become impossible. The urgency pressed upon the scientific community like a weight to gather what they could before the visitor vanished forever. In the laboratories where spectra were analyzed, in the observatories where operators tuned delicate instruments, there lingered a collective awareness that they were chasing not only data but history. Atlas would not wait. It was in these quiet, relentless nights of measurement that the interstellar visitor revealed its most disquieting truth, that even with the best instruments humanity possessed, certainty remained elusive. And in that uncertainty dwelled the first flicker of fear that perhaps this was not merely an object to study, but a riddle whose answer could shape humanity's fate. As the data sharpened, so too did the unease. Orbital models are, in theory, the most solid ground astronomy can stand upon. A few positions measured against the stars, a few nights of careful tracking, and celestial mechanics can unfurl an entire future path with astonishing accuracy. But with 3I, Atlas, the calculations resisted the neatness scientists had come to expect. The orbit carried a whisper of deviation, a stubborn uncertainty that refused to vanish no matter how many refinements were applied. The numbers suggested a hyperbolic trajectory, unmistakably interstellar. Yet buried within that broad confidence lay troubling subtleties. Tiny deviations, fractions of degrees, imperceptible shifts in acceleration hinted that Atlas might not be a simple wanderer passing harmlessly through. A handful of simulated trajectories whispered of intersections with Earth. They were rare, improbable, weighted heavily against reality, and yet their presence could not be erased. In orbital dynamics, even a 1 in a million probability carries the heavy weight of consequence when the stakes are planetary. The unsettling part was how these probabilities emerged. For most near-Earth asteroids, errors shrink quickly as more observations are added. Their paths converge into reliable certainty, but Atlas defied that expectation. Its orbit seemed slippery, as though the cosmos itself withheld clarity. Each new night of data brought refinement, yes, but also fresh anomalies. Some wondered whether non-gravitational forces were at play, outgassing jets too faint to see, or radiation pressure nudging the object in ways too subtle to confirm. Others muttered of more exotic explanations, recalling how Oumuamua had displayed similar anomalies that no consensus had ever fully explained. The possibility of Earth intersection, however remote, cast a long shadow. Quiet conversations in observatory hallways grew tense. Policy advisors were briefed in cautious tone. What would it mean if a body from another star, moving at tens of kilometers per second, had even the slimmest chance of striking Earth? Unlike local asteroids, which could sometimes be diverted with time and technology, an interstellar intruder brought with it impossible velocity and unpredictable behavior. There would be no practice runs, no rehearsals, only a single encounter. The idea unsettled not only scientists but philosophers. Humanity's story had long carried myths of falling stars, omens of destruction hurled from the heavens. Now, in the sterile light of computer models, those myths took on new resonance. A visitor from another star was not merely an intellectual curiosity, it was a reminder that the universe's randomness does not spare us. The very fact that such a trajectory could exist, even as a mathematical outlier, pressed against the illusion of safety humanity has cultivated beneath the dome of the sky. In press releases and interviews, astronomers stressed caution, probability, restraint. They reminded the world that the overwhelming likelihood was one of harmless passage. But behind those reassurances lay the unspoken tension of scientific honesty. Low probability is not zero, and zero cannot be declared until the object has passed. The whisper of danger lingered, like a faint hum beneath the louder chorus of discovery. And so, in observatories and laboratories across the globe, the pursuit of clarity continued. Orbital solutions were recalculated, error bars tightened, simulations run endlessly on supercomputers. Each time, the same haunting truth returned: improbable, unlikely, yet never impossible. Atlas's presence in our skies was more than an astronomical event. It was a reminder that chance, however slim, governs even the fate of worlds. To the public, the object was quickly labeled a comet, because what else could it be? For centuries, bright wanderers had streaked across the sky, their luminous tails etched into memory as omens and portents. Yet 3I, Atlas refused to wear the comet's traditional garb. Its form was strangely reticent. There was no sweeping plume, no glowing veil of vapor, no magnificent streamer unfurled across the darkness. It glimmered dimly, stubbornly, as though it were determined not to fit the mold. In those early weeks, astronomers tried to force comparisons. They spoke of comets long faded, whose activity dwindled after countless orbits, their volatile ices baked away until little more than rock remained. They wondered if Atlas was such a husk, hardened by eons of exposure to interstellar radiation. Yet the comparison faltered, for it did not behave like a dormant relic either. Its light shifted unpredictably, as though fragments of dust or gas were released in uneven bursts. It was comet-like, but only in glimpses. This ambiguity brought discomfort, for classification is not merely a matter of language, but of expectation. Comets are familiar, their behavior is charted, their dangers quantified. If Atlas had been a comet in the ordinary sense, it would have offered a measure of reassurance. But its refusal to conform suggested a deeper mystery that this interstellar fragment carried within it processes unfamiliar to our solar system. Perhaps its chemistry was alien, its surface scarred by forces our instruments could not yet trace. The comparisons deepened unease in another way. Comets, after all, have long histories of fear. They were once believed to bring plagues, to announce the fall of kings, to herald calamities written into the very sky. Those fears had been banished by science, replaced by an understanding of frozen volatiles and predictable orbits. Yet Atlas seemed determined to revive the dread, not by superstition, but by science itself. Its resistance to categorization unsettled precisely because it made prediction harder. What it was became inseparable from what it might do. The object's faint activity further complicated orbital calculations. If outgassing jets were indeed pushing against its body, even slightly, they could alter its path in unpredictable ways. For ordinary comets, these forces are modest and eventually accounted for, but in the case of a hypervelocity interstellar body, even tiny accelerations multiplied into vast uncertainties over astronomical distances. To call it a comet, then, was both a convenience and a confession. It was the closest analogy we had, but not a true description. And so, the comparisons took on a double edge. On one hand, Atlas was placed alongside familiar comets to soothe public imagination, to fit it into the drawers of existing knowledge. On the other, scientists knew those drawers did not quite close. The object had one foot inside the known and the other in the unknown, straddling categories in a way that forced both fascination and apprehension. The longer it lingered in observation, the clearer this paradox became. Atlas was like a comet, yet unlike any comet we had seen. Its tail was absent, its brightening irregular, its chemistry tentative and foreign. It whispered of kinship with the icy bodies that wander our system, while simultaneously declaring itself a stranger. And in that refusal to be pinned down, it carried the unease of something far more dangerous: unpredictability. Because in the end, humanity's fear was not of comets or asteroids themselves, but of what cannot be foreseen. To predict is to survive. To misjudge is to risk catastrophe. Atlas, in its half-comet, half-something-else nature, embodied that razor edge of uncertainty, and it reminded us that in the cosmic ledger, ambiguity is often the most terrifying entry of all. The unease deepened when astronomers noticed a subtle irregularity in the object's path. At first, the data seemed trivial fractions of a percent in velocity, deviations too small to notice without exacting measurements. Yet the more precisely the orbit was refined, the more these tiny shifts mattered. 3i. Atlas was not moving quite as it should. According to Newton, to Einstein, and to centuries of celestial mechanics, a body in space obeys the dictates of gravity alone, unless acted upon by another force. But Atlas whispered of something more. Its acceleration was not entirely explained by solar gravity. Even when radiation pressure and the faint push of possible outgassing were accounted for, residual discrepancies lingered. It was as though the interstellar fragment carried with it a secret, a force unaccounted for, a whisper of defiance against our model. Such irregularities are not unprecedented. Oumuamua, the first interstellar object, had displayed a similar anomaly, a faint, non-gravitational acceleration that scientists still debate today. Some attributed it to invisible jets of gas, others to exotic ices sublimating in ways unfamiliar to us. A minority dared to suggest something far stranger, that it might be a fragment of technology, a thin sail pushed by starlight. Whatever the cause, the lesson was clear: our understanding was incomplete. And now, with Atlas, that lesson returned, heavier, darker, more insistent. In the conference halls and online forums where astronomers exchanged notes, voices lowered when the anomalies were discussed. It was not yet proof of anything extraordinary, but it was enough to strain confidence. If the trajectory could not be perfectly explained, then its long-term predictions became unreliable. And when an object moves at tens of kilometers per second on a path that even faintly approaches Earth, unreliable is a dangerous word. The unsettling part was not only the deviation itself, but its implication, that something we did not fully understand was shaping the fate of this body. Was it merely chemistry, frozen volatiles escaping in ways unlike those of solar comets? Or was it some deeper process, one tied to interstellar conditions humanity had never directly measured? And if it was not natural at all, if some structure, some hollow, some manufactured geometry lay hidden within, what then? Einstein's theories of relativity held firm in describing the broad arc, but within the fine detail, the rules wavered. It was as though Atlas existed at the border between known and unknown physics, a reminder that the laws we trust are, in truth, provisional descriptions of what we have seen, not guarantees of what we will see. Each fraction of deviation became a philosophical splinter, prying open questions about the completeness of science itself. The public, of course, heard little of this nuance. Press releases spoke of an exotic interstellar comet, fascinating but harmless. Yet within the professional community, a quiet tension grew. The object's refusal to behave precisely as expected made it not only an enigma, but a potential hazard. To plan for defense, one must predict. To predict, one must trust the numbers. And Atlas, in its quiet defiance, reminded us that the numbers can sometimes lie. Here, in this subtle trembling of celestial mechanics, lay the seed of dread. For if the universe could send a messenger that disobeyed our rules, even slightly, what else might lie beyond the horizon of our understanding? The anomaly was not just a puzzle, it was a warning, carved silently into the trajectory of a stone from another star. As weeks passed, the object became more than a puzzle of numbers. It became a mirror in which humanity projected its deepest uncertainties. In research papers, careful language cloaked the rising tension, further study required, anomalous data pending confirmation. But in late-night conversations, in the quiet urgency of private emails, the divide became sharper. Scientists themselves were split, not in ignorance, but in fear. One camp insisted on restraint. They saw 3I, Atlas, as a fragile cometary fragment, its irregularities explainable by outgassing too faint to observe directly. They reminded colleagues of how Oumuamua had once sparked talk of alien probes, only for mundane explanations to remain most plausible. Do not repeat the mistakes of speculation, they warned, urging patience, data, caution. Yet another camp leaned into unease. They pointed to the stubborn deviations, the refusal of orbital solutions to converge neatly. They asked why its brightening was erratic, why its apparent size seemed to fluctuate, why the chemistry teased but never declared itself. These were not the fingerprints of a standard comet, they argued. Something stranger was unfolding, and to dismiss it was to blind ourselves to possibility. The arguments carried weight not just in science, but in policy. A minority of orbital projections had placed Earth uncomfortably close to the visitor's potential future path. Most solutions were safe, yes, but those lingering probabilities remained. To some, this was negligible statistics as usual, the unavoidable fuzziness of early data. To others, it was enough to justify caution bordering on alarm. For when extinction lies even faintly upon the table, no percentage feels small enough to dismiss. This division spilled quietly into the world beyond academia. Leaks reached journalists, who in turn amplified whispers into headlines. Some painted Atlas as harmless, another fleeting curiosity of the cosmos. Others spun darker tales, framing it as a looming threat, an interstellar harbinger. The truth lay somewhere in between, but the divide itself was telling. When knowledge falters, imagination rushes in, often armed with fear. Among the scientific community, the divide carried a deeper resonance. It was not merely about one object, it was about what kind of universe we inhabit. Do we live in a cosmos where interstellar wanderers are just debris, icy shards cast adrift, remarkable only for their journeys? Or do we live in a cosmos where such visitors can carry anomalies, forces, or even intentions that resist our understanding? The answer to that question shaped not only the theories scientists chose, but the anxieties they carried into the night. In time, the debates themselves became part of the story. At conferences, papers presented side by side seemed less like complementary studies and more like competing realities. A comet of alien ice, a shard of planetary wreckage, a messenger of unknown physics, the possibilities clashed, unresolved. And each possibility carried its own weight of consequences, scientific and existential. Thus, the object became not just an interstellar fragment, but a fault line within human knowledge. On one side lay comfort, the reassurance that familiar physics and probabilities would prevail. On the other lay dread, the recognition that even small deviations, even rare anomalies, can expose how little we truly know. And so the community divided not into camps of right and wrong, but into camps of faith and fear. Faith in the resilience of known science, or fear that beneath the numbers lay something far stranger and far more perilous. As the debate unfolded, attention turned backward toward the possible birthplace of this strange fragment. If it did not come from here, then from where? Orbital tracing suggested origins far beyond the local neighborhood, perhaps from a distant arm of the Milky Way, perhaps from a sun now dimmed to obscurity. Its hyperbolic path, when projected into the deep past, dissolved into the great sea of stars, vanishing into uncertainty. Yet even within uncertainty, scientists sought story. The leading models suggested ejection. In the crowded youth of star systems, planets jostle like restless siblings, gravitationally tugging at each other until the smallest bodies are cast adrift. A comet orbiting too near to a giant planet can be flung outward, its speed pushed past escape velocity, hurled forever into interstellar exile. Thus, 3I, Atlas may have once belonged to another solar system's infancy, a fragment from a nursery where worlds were born and destroyed. To imagine its past was to peer into chaos. Perhaps it had once circled an alien sun, a cold companion orbiting silently for millions of years until some planetary upheaval cast it outward. Perhaps it was part of a shattered moon, torn apart by collisions so violent that whole landscapes were erased in fire. Or perhaps it had been icy debris at the edge of a system, waiting in the shadows until a passing star's pull sent it outward. Whatever the story, it was a story of loss of something broken and banished, wandering into the void. Computer simulations added richness to this speculation. Models of planetary systems suggested that for every world like Earth that survives, countless fragments are thrown away. Most drift forever in interstellar darkness, unseen. Yet now and then one finds its way across the galaxy and into another system, like a letter lost for eons before arriving at a stranger's doorstep. Atlas was one such letter, its envelope battered, its ink smudged, but carrying within it secrets of another star's story. There was poetry in this thought, but also unease. For if Atlas was ejected violently, then it carried within it the scars of catastrophe. Its irregular shape, its strange rotation, its refusal to behave like a simple comet, these could all be signs of trauma, of an object forged in destruction. To study it was to glimpse the violence of the universe, the truth that creation and ruin are inseparable. Some speculated even further. If Atlas had traveled for millions of years, what had it endured? Interstellar radiation would have battered its surface, stripping volatiles, hardening it into something alien. Cosmic dust may have pitted and scarred it, altering its chemistry in ways unfamiliar to Earth. Even the faint pull of galactic tides, the great invisible currents of the Milky Way, would have shaped its path. It was not merely an object, it was a survivor, a relic that had endured the brutality of time and distance. And yet, the question lingered, why here, why now? Of all the vastness of the galaxy, why had this fragment's wandering led it into the tiny compass of our solar system, into the gaze of human beings? Was it coincidence alone, or was it part of a deeper truth, that the galaxy is restless with such fragments, and that we stand exposed upon a cosmic shoreline where the waves will sometimes throw wreckage at our feet? The thought was humbling. Atlas was not just a rock or an icy shard, it was a messenger that spoke of systems unseen, of histories erased, of worlds broken long before ours was born. And in carrying those stories across the void, it also carried a reminder that our world too is fragile, and that exile and ruin are written into the fate of stars and planets alike. Once the idea of ejection took hold, scientists began to see Atlas, not as a solitary curiosity, but as part of a much larger drama, the grand game of cosmic billiards that governs the galaxy. In every star system, from the youngest to the most ancient, worlds dance around their suns in precarious balance. Giant planets in particular act as cosmic players, their gravity both a guardian and a menace. They can shepherd debris into stable orbits, or fling it outward with ruthless efficiency. Imagine the early history of a solar system. Disks of dust and gas swirling, colliding, merging into planets. The largest bodies seize control, tugging at smaller neighbors, pulling comets inward or outward. Some of those comets plunge into suns, vanishing in a blaze. Others smash into planets, reshaping surfaces, seeding atmospheres. And some, caught at just the right angle, are hurled outward with such velocity that they escape forever. These exiles become wanderers, interstellar orphans cast adrift in the galaxy's endless dark. Atlas was likely one such exile, a fragment thrown from its birthplace not gently, but violently, like a stone slung from a sling. Perhaps it was brushed by a giant planet larger than Jupiter, sent careening outward at tens of kilometers per second. Perhaps it was struck by another body, the impact not enough to obliterate it but sufficient to launch it into a new, merciless trajectory. Whatever the cause, it became part of the galaxy's invisible tide, a steady flow of interstellar debris weaving silently between the stars. The scale of this process is staggering. Simulations suggest that for every star in the Milky Way, trillions of icy bodies may have been ejected over time. They wander aimlessly, unseen, until chance brings them into the path of another star system. Most pass unnoticed, too small or too dark to be detected. But now and then, one is spotted. And in those moments, humanity glimpses the vast machinery of stellar creation, not in the form of glowing nebulae or brilliant novas, but in a lonely fragment hurtling through space. The idea unsettled even as it fascinated. If Atlas was one of trillions, then the universe was far less stable than we imagine. The night sky may appear serene, but beneath that serenity lies endless motion, endless collisions, endless banishments. Every planet, every moon, every asteroid carries the potential to become a projectile in this galactic billiards match, and every so often, those projectiles cross paths with us. The analogy extended further. Just as pebbles skimmed across water leave ripples, so too do these ejected fragments ripple through knowledge. They carry chemistry from their home stars, altered by their travels, bearing clues about systems we may never see directly. Studying them is like studying fossils from alien worlds. Each grain of dust, each spectral line is a whisper from a place light years away. Atlas was not merely a threat or an anomaly. It was a fragment of galactic memory, preserved in silence. Yet this perspective also deepened dread. For if such wanderers are common, then the possibility of one striking Earth is not fantasy but inevitability over geological time. Chicxulub was proof enough that planetary surfaces are not safe havens. Atlas was a reminder that the dice of gravity are always rolling, and sometimes the throw lands against us. Cosmic billiards is not a game we watch from the sidelines, it is a game we are already playing, whether we like it or not. Thus, Atlas became more than a speck of light. It became a symbol of the galaxy's restlessness, of the ceaseless shuffling of debris across unimaginable distances. A shard from a shattered past, flung outward by the blind mechanics of gravity, now found itself crossing our sky, and in its brief appearance, it forced us to confront both the grandeur and the menace of the universe's eternal motion. To imagine the path of 3i, Atlas was to imagine silence stretched across eternity. Long before it brushed the sun's domain, it had already endured a voyage so immense that human language strains to describe it. Astronomers traced its trajectory backward into the void, watching as calculations dissolved into uncertainty beyond tens of millions of years. Somewhere in that immeasurable gulf, its story began, not here, not near, but in the orbit of another star, perhaps long extinguished. What had it seen? If rocks could carry memory, then Atlas would remember a darkness more profound than any we know. For while the solar system is alive with light and warmth, the interstellar medium is a place of near absolute cold. Temperatures hover only a few degrees above absolute zero. Cosmic rays bombard ceaselessly, stripping molecules, altering surfaces grain by grain. Dust clouds drift invisibly, colliding with the body like sand on glass, leaving scars written over millions of years. It is possible that Atlas drifted like this for 100 million years, or longer. Time in such a place loses all meaning. Stars are seen not as fixed companions but as migrants themselves, rising and falling across the galactic plane. Nebulae expand, dissolve, reform. Armies of other exiled fragments sweep silently through the dark, some never encountering a star again. Atlas was one among countless such orphans, locked in a journey where no beginning and no destination could be marked with certainty. The sheer scale humbles imagination. If its path carried it even a fraction of the Milky Way's span, then it has traveled distances that dwarf the very notion of human history. Civilizations rise and fall in the blink of a galactic eye. Empires collapse, species vanish, whole landscapes change, while Atlas continues its silent voyage, indifferent to all. It is a reminder that our lifespans, even the lifespans of worlds, are fragile threads against the tapestry of cosmic time. Yet its endurance is no less astonishing. For millions of years, the fragment held itself together. Impacts may have chipped it, radiation may have pitted its skin, but still it remained. Perhaps it carried frozen volatiles beneath its surface, preserved like ancient ice in a vault. Perhaps it bore minerals forged in alien heat, telling of a planetary forge we will never see. Whatever it carried, it endured. An arc of matter, ferrying secrets of another system across the gulf. The silence of that voyage is almost unbearable to imagine. 1 billion years of night, punctuated only by the distant glimmer of stars, none close enough to warm, none bright enough to guide. And yet, in the blind arithmetic of motion, Atlas continued, waiting for chance to deliver it into another sun's embrace. Chance, in this case, meant ours. The thought unsettled astronomers, not merely because of what Atlas was, but because of what it implied. If one fragment could cross such distances and arrive here, then many must do the same. Our solar system is not isolated but porous, its borders open to the endless traffic of the galaxy. How many fragments have slipped past unnoticed? How many more will follow? And what stories or dangers might they carry? To see Atlas in a telescope was, therefore, to see not just a single visitor, but the shadow of an entire population, 1 billion silent travelers crossing the void, any one of which could stumble upon Earth. In this realization lay both wonder and dread. Wonder at the immensity of the cosmos's memory, dread at the reminder that the universe is never still, never safe, never truly ours. At last, the interstellar wanderer crossed the invisible frontier that defines our cosmic home, the heliopause. This is the boundary where the solar wind, the breath of our star, pushes back against the interstellar medium. Beyond it lies the true galactic ocean, filled with particles and radiation unfiltered by the sun's protection. Few human-made objects have ever touched this realm. Voyager 1 and 2, drifting slowly outward, their instruments straining against the cold and dark. But 3I, Atlas had crossed this threshold in silence, slipping unnoticed into the domain of our star. The heliopause is not a wall but a shifting veil, rippling under the pressure of solar storms, bending and stretching like a fragile skin. To pass through it is to enter a new environment, one dominated not by the galaxy at large, but by the influence of the Sunday. Charged particles stream outward in a constant gale, shaping magnetic fields, driving shock fronts that echo far into space. For Atlas, this crossing was profound. After millions of years adrift in the unbounded dark, it now encountered warmth, light, and force, unlike any it had felt since leaving its birthplace. Astronomers considered what that meant for the object's surface. The first touch of solar photons would awaken ices that had lain dormant for ages, sublimating in jets of gas, however faint. The solar wind might stir a shroud of plasma, subtle enough to escape direct detection, but strong enough to nudge its trajectory. Dust on its surface, long fused into place by radiation, might lift and drift away, leaving the body to shimmer faintly against the black. In that moment, the interstellar fragment was transformed from relic to participant, entering into dialogue with the machinery of our star. For scientists, this was an opportunity. By watching closely as Atlas responded to solar influence, they could glimpse its true nature. Was it rich in volatiles like a comet carrying the frozen fingerprints of alien chemistry? Or was it hardened, stripped of such riches by its long exile? The heliopause crossing was a kind of awakening, an experiment staged not in laboratories, but in the laboratory of the universe itself. Yet with that awakening came uncertainty. If solar radiation drove subtle jets from the object's surface, it might explain the irregularities in its motion. But those same jets made prediction harder, altering its path in ways too complex for certainty. In the balance between gravitational law and volatile freedom, Atlas played its own game, one that humanity could only watch with nervous fascination. The heliopause crossing also carried symbolism. To us, it is the edge of the known world, the final border of the sun's dominion. Beyond it lies the true vastness of the Milky Way, where human instruments falter and imagination stretches thin. For Atlas, it was merely another milestone, another threshold in a journey defined by thresholds. Yet, in passing through it, the object became part of our system's story. Like a traveler entering a city, it moved from anonymity into recognition, from nameless exile into the focus of our watchful eyes. What lay ahead was the inner system, brighter, warmer, more dangerous. The sun's power would intensify with every million kilometers. Planets would loom as gravitational waypoints, their pulls subtle but cumulative, and Earth, fragile and luminous, lay among them. The heliopause was not merely the crossing of a border, it was the beginning of risk. For once the interstellar fragment entered the solar realm, chance itself began to weave possibilities that no one could fully deny. Thus, the heliopause marked a turning point. Atlas was no longer a silent wanderer in the galactic dark. It had become an actor on our stage, subject to the same forces that govern comets, asteroids, and planets. But unlike those familiar bodies, it carried with it the unknowable scars of another star. To cross the heliopause was to awaken from one sleep into another, and to remind humanity that the universe does not end at the edge of our sun's breath, but stretches endlessly beyond, filled with travelers we may never predict. When astronomers turned their attention from origin stories to the mathematics of the object's path, the tone grew heavier. Orbital mechanics, normally a source of comfort in its precision, became a crucible of unease. For though the grand arc of 3I, Atlas was clear an interstellar visitor on a hyperbolic course, the fine details carried unsettling implications. Every orbit is a tapestry woven from initial conditions, a fraction of a degree in inclination, a sliver of uncertainty in velocity, and the future path of a body transforms utterly. Computers ran the numbers endlessly, simulating not one trajectory but millions, each variation like a possible thread of fate. Most showed the visitor passing at a safe, though narrow, distance. But here and there, within the spread of possibilities, Earth's orbit intersected with its own. These scenarios were few, improbable, but stubbornly present. The mathematics revealed how precarious such encounters truly are. A gravitational nudge from Jupiter at just the right angle could shift the course inward. A burst of sublimated gas, invisible yet real, could act as a thruster, altering velocity by fractions of a meter per second, small changes that multiplied into planetary consequences over millions of kilometers. The equations were impartial. They did not care for reassurance. They simply listed outcomes, among them both safety and catastrophe. Impact scenarios took form within these models. A body a kilometer across, traveling at tens of kilometers per second, carries kinetic energy on a scale that defies human reckoning. Should such an object strike Earth, it would release the force of millions of nuclear weapons, gouging a crater vast enough to alter climate, ecosystems, and civilization itself. Even a smaller fragment, 100 meters across, could devastate a continent. These were not speculations born of fear, but calculations grounded in the cold numbers of physics. The mathematics also underscored the fragility of prediction itself. Orbital models improve with time and data, yet never reach perfection. The smallest forces, thermal radiation, asymmetric jets of gas, magnetic drifts, can distort long-term forecasts. With local asteroids, centuries of observation refine predictions into confidence. But with interstellar visitors, the window is narrow, the data sparse, the uncertainties magnified. To speak of probabilities is to confess ignorance, to admit that in the cosmic lottery, we may never know the winning number until the draw is over. For astronomers, the exercise was both necessary and haunting. They calculated probabilities not to sensationalize, but to prepare. For policymakers, the numbers became dilemmas. How should governments respond to an object whose impact risk is low but not zero? What resources should be committed, and what consequences admitted when the evidence remains ambiguous? Between mathematics and policy lay the chasm of fear. Yet there was also wonder. The sheer complexity of orbital mechanics reminded scientists of the delicate clockwork in which Earth is embedded. Planets tug and bend the paths of countless bodies. The sun's gravity binds and releases with invisible power. Every meteor that streaks across the sky, every comet that glows at dawn, is a testament to this grand choreography. Atlas, in its defiance of predictability, reminded us of both the elegance and the menace of that cosmic dance. The numbers offered no certainty, only possibility, and in possibility lay both terror and humility. For to gaze at a simulation of Atlas striking Earth is to confront extinction not as myth, but as equation, a line of mathematics indifferent to human hope. It was not that Atlas would strike, but that it could, and that possibility, however remote, was enough to force humanity to look again at the night sky and remember that the heavens are not merely beautiful, but perilous. Once the numbers were laid bare, the simulations of impact began. They were not fantasies, but precise models, built on physics, geology, and precedent. Supercomputers rendered scenarios in grim detail, fiery entries through the atmosphere, shock waves spreading outward, oceans surging into tsunamis, skies darkened by ejected dust. Each model whispered the same refrain that if 3I, Atlas struck Earth, the event would not be a mere disaster, but a rewriting of history. The energy was unimaginable. A 1-kilometer object, moving at interstellar speed, would strike with force beyond comprehension. Tens of millions of megatons released in an instant, heat enough to vaporize oceans, seismic waves strong enough to rattle the crust of continents. The point of impact would be annihilated utterly, reduced not to rubble but to plasma. Surrounding regions would burn in storms of fire, forests igniting as shock waves raced across the land. The atmosphere would choke with dust and sulfur, blotting out sunlight for years, perhaps decades. Crops would fail, ecosystems would collapse, and civilization itself would falter under the weight of a new prolonged night. Smaller impact scenarios were no less chilling. If the object measured only a few hundred meters across, it could still unleash devastation on a continental scale. Cities would vanish, coastlines would be remade, millions would perish in the initial hours, with billions more left to contend with famine and cold. Even fragments, splintered pieces trailing behind, could deliver destruction in clusters, hammering multiple regions simultaneously. The terror lay not only in the object's bulk, but in its velocity. Interstellar speed made every gram a weapon. The Chicxulub impact loomed large in comparison. 66 million years ago, a body perhaps 10 kilometers across struck Earth and ended the reign of the dinosaurs. Its aftermath left scars still visible today, both in the Yucatan Peninsula and in the fossil record. Atlas was smaller perhaps, but its speed was far greater, and speed translates into energy. In certain simulations, the devastation rivaled Chicxulub's scale, enough to plunge the modern world into collapse. Astronomers, of course, reminded themselves of probabilities. Such outcomes were rare, the chances vanishingly small, but computers are indifferent to comfort. They show what could happen, not what will, and what they showed was a portrait of apocalypse. Watching those simulations, scientists felt not only professional concern, but personal dread. For in the numbers lay a reminder that our planet is fragile, our survival conditional, our civilization temporary. Yet even in those grim scenarios, there was a strange solemnity. To see Earth from above, struck by a fragment from another star, was to glimpse our world's vulnerability written across cosmic scales. It was a lesson older than humanity itself, that the universe creates and destroys without intention, without malice, without warning. The dinosaurs had learned it. Countless species before and after had learned it, and one day we too may learn it again. Thus the worst-case scenario took form, not as a fantasy of fiction, but as a sober calculation. a body from another system, carrying with it the cold indifference of galactic exile, slamming into Earth with energies sufficient to end an age. Low in probability, yes, but not zero. And in that small remainder lay the weight of terror, pressing upon every astronomer who ran the simulations, who watched the digital Earth die in silence, and who then turned back to the real Earth, fragile and alive, and wondered how much time remained before chance rolled against us. The visions of catastrophe were not abstract. Earth's own scars told the story. When 3I, Atlas, appeared in simulations as a fiery impactor, scientists could not help but look back into the geological record, to the evidence carved into stone and fossil, to the wounds the planet still bears from ancient collisions. The Chicxulub crater in Mexico is the most famous, a vast scar hidden beneath the Yucatan Peninsula, marking the end of the Cretaceous. An object 10 kilometers wide had struck, unleashing energies that extinguished 3/4 of all life, including the dinosaurs. The echoes of that single event reshaped evolution itself, opening paths that led eventually to the rise of mammals and to us. The message was clear: impacts are not mere disasters, they are turning points in planetary destiny. Other scars lie across the globe. The Barringer crater in Arizona, just over a kilometer across, was carved 50,000 years ago by a fragment far smaller than Atlas. The Tunguska event in Siberia in 1908 flattened 2,000 square kilometers of forest, though the object responsible never even touched the ground, disintegrating instead in the atmosphere. These were small compared to Chicxulub, but their devastation was vivid enough to remind us of what falling sky means. The moon, too, bears witness. Its face is a mosaic of impacts, each crater a frozen memory of cosmic collisions. Where Earth's surface renews itself with oceans and tectonics, the moon preserves its scars. To gaze at it is to gaze at the history of bombardment, to be reminded that our world is not spared by destiny, only by chance. The presence of Atlas revived these memories with new urgency. If an interstellar object were to strike, the devastation could surpass anything in recorded history. And yet the past also offered strange solace. Earth had endured countless impacts before, each one reshaping but not destroying the planet entirely. Life had recovered, often more diverse than before. Catastrophe, in this view, was also creation. But for humanity, a species bound by fragile civilization, the stakes were different. Recovery on geological timescales would mean nothing to a society measured in decades. The lesson of scars is dual. They remind us of our vulnerability, but also of the persistence of life itself. They whisper that Earth has survived, that extinction is not the end of the planet, but the end of epochs. Atlas, in its hypothetical strike, would not end the world, but it could end our world, the world of cities and nations, of language and memory, of fragile networks strung across the globe. As astronomers studied these scars, they realized they were not merely cataloguing history. They were gazing into a mirror, seeing in past impacts the reflection of possible futures. Chicxulub was not just an ancient disaster, it was a warning written in stone. Tunguska was not only a curiosity of history, it was a rehearsal for what might come. And Atlas, moving silently across the sky, became the embodiment of those warnings, a reminder that the universe does not forget to roll its dice. What made the dread so insidious was not certainty, but improbability. Had the numbers declared that 3I, Atlas, was on a direct path to Earth, humanity would at least have clarity, terror, yes, but clarity. Instead, the truth lived in probabilities so small they seemed almost dismissible, yet not small enough to erase. Astronomers spoke in fractions of percentages, in ranges of likelihood so remote they vanished into decimal places. But the human mind does not rest easily when extinction is written, however faintly, into the equation. It is the paradox of the unlikely, events that should not happen, but sometimes do. Statistically, a single interstellar object striking Earth within the span of a human life is nearly impossible. But across the billions of years of planetary history, improbable events have happened again and again. The dinosaurs did not vanish because their odds were high. They vanished because their odds were not zero. For policymakers, this probability became a nightmare of decision. How much resource should be spent to confront a threat that was almost certainly harmless, yet carried consequences so vast that even a 1 in a million chance demanded attention? How does one weigh money, time, and global coordination against a danger that might not exist at all? In that dilemma lay the most human of fears, not of death itself, but of uncertainty, of the inability to control or predict. The public, too, absorbed this unease in fragmented whispers. To most, Atlas was just another headline, an exotic visitor from beyond the stars. But to those who listened closer, the tremor of improbability lingered. Online forums filled with speculation. Documentaries spun narratives of doom. Fiction leapt to claim the image of an alien shard hurtling toward Earth. Culture itself became an echo chamber of low-probability terror, where imagination amplified what mathematics struggled to restrain. Scientists wrestled with this tension in their own way. Some dismissed the worst-case scenarios as distractions, urging focus on the data. Others admitted quietly, in private, that the dread gnawed at them too. For in truth, what unsettled them most was not simply Atlas, but the reminder it carried that improbable disasters are part of the fabric of existence. Humanity lives under skies where extinction-level events are rare but never impossible. The improbable is not the impossible. This truth has shaped history before. Great floods, volcanic eruptions, pandemics, all statistically unlikely in any given year, yet all inevitable given enough time. Atlas belonged to that same category of dread, an event that might never touch our generation, but which someday, in some age, would touch Earth again. To imagine otherwise was to indulge in denial, and so the improbability became its own kind of terror. Not a scream, but a whisper, not a certainty, but a shadow that stretched across thought. For the universe, indifferent and vast, does not promise safety. It only promises that given enough time, even the rarest events unfold. In that truth lay the weight of dread, a weight heavier than certainty, because it left humanity staring into the abyss of possibility without knowing whether the abyss would ever stare back. In the search for clarity, scientists turned again to the foundations of physics, Einstein's great map of spacetime. Gravity, as he described it, was no longer a simple force pulling across voids, but the very curvature of reality itself. Every mass, no matter how small, bends the fabric of spacetime, and every moving body follows those bends as faithfully as a river follows its channel. To understand the path of 3I, Atlas, one had to imagine not a stone moving through emptiness, but a traveler sliding across invisible valleys and ridges sculpted by stars and planets. Einstein's equations offered reassurance in their elegance. They described with uncanny precision the arcs of planets, the bending of light, even the spirals of galaxies. Yet in the case of Atlas, there was discomfort, for when astronomers laid its path upon that great map, tiny irregularities persisted. The fragment moved where spacetime said it should, and yet not quite. Its velocity seemed too great, its subtle accelerations unexplained, as if some unseen hand had brushed against its course. To confront this was to confront the limits of relativity itself. Not in the sense of failure, the equations still ruled the grand arc, but in the sense of incompleteness. Einstein had unified space and time into a single fabric, but that fabric remains stitched with mysteries. Dark matter, dark energy, quantum fluctuations all suggest that the map is not the territory, that what we see is only a shadow of deeper laws. Atlas, in its stubborn deviations, became a symbol of this incompleteness. Some astronomers speculated that the answer lay in scale. Relativity governs the vast, quantum mechanics the minute, and in the borderlands between them lie phenomena not yet reconciled. Perhaps Atlas, in its interstellar exile, carried within it conditions so alien that it exposed cracks in our models. Or perhaps it was simply that our instruments were not sensitive enough, our measurements too coarse to capture the truth. Either way, the unease remained. The map bent reality into elegance, but the traveler did not wholly obey. In the public imagination, Einstein was invoked as a kind of cosmic guardian, the man whose vision made sense of the stars. To invoke his name in connection with Atlas was to frame the object as a test, perhaps even a challenge, to the very bedrock of modern science. Could a rock from another system remind us that even Einstein's vision was but a chapter, not the whole story? Philosophers seized upon the symbolism. If space-time itself could be unsettled by a fragment of wandering stone, what did that say of humanity's place in the cosmos? We rely on order, on predictability, on the idea that the universe is a book we can read, but perhaps Atlas was a reminder that some pages are missing, torn away, scattered among the stars. In the end, Einstein's map still guided the models. The hyperbolic arc of Atlas was drawn with his mathematics. The simulations unfurled along the curvature he described. Yet within the margins, within the small deviations that haunted prediction, lay the possibility that space-time was not fully revealed. The visitor had become more than a threat or a curiosity. It had become a question written into the very geometry of the universe, a question Einstein himself might have pondered had he lived to see it. What hidden folds of reality might be revealed by a stone from the stars? If Einstein had offered the grand map of space-time, then quantum physics whispered of the tremors beneath that map, subtle, unpredictable fluctuations that blur the certainty of trajectories. In the case of 3I, Atlas, some scientists wondered whether such whispers could matter. Could the tiniest quantum effects, normally dismissed in the mechanics of celestial bodies, leave fingerprints on the path of a fragment from another star? In principle, quantum mechanics governs everything. Every atom of Atlas, every molecule of frozen ice or fractured rock, exists in a haze of probabilities. On human scales, these uncertainties vanish, averaged into the solidity of stone. But across millions of years and trillions of kilometers, even small uncertainties may cascade, magnified by time. Could this explain why Atlas seemed to slip through predictions, why its orbit resisted perfect convergence? The speculation remained fringe, but it captured imaginations. Perhaps vacuum fluctuations, the jittering energy of empty space, nudged its surface molecules unevenly, slowly altering its spin. Perhaps quantum tunneling in its icy core had caused trapped volatiles to escape in strange patterns, invisible but real. Perhaps even the wave function of its bulk had spread across space like a ghost, collapsing into certainty only when observed by human instruments. Most astronomers resisted such leaps. The mathematics of orbital motion, they argued, did not require quantum ghosts to explain anomalies. Outgassing, radiation pressure, measurement error, these sufficed. Yet a small number of theorists leaned closer, sensing in Atlas not just an astronomical puzzle but a philosophical one. For if an object drifting through interstellar dark for millions of years could carry the cumulative mark of quantum chance, then the universe itself was stranger than even Einstein dared to suggest. This line of thought blurred science into philosophy. If chance rules even the stones that cross the void, then destiny itself is a fragile illusion. The dinosaurs did not die because it was inevitable, but because probability permitted it. If Atlas had struck Earth, it would not have been by design, but by the same quantum indifference that allows particles to slip through barriers, stars to ignite, and universes perhaps to emerge. The thought unsettled more deeply than talk of craters or explosions, for physics usually offers stability laws, constants, a sense of order. Quantum whispers offer only possibility, uncertainty, indeterminacy. To imagine Atlas as a quantum traveler was to imagine a cosmos not governed by inevitability, but by dice, rolled endlessly in silence. And yet, there was a strange poetry in the idea, a fragment of another star system, scarred by exile, drifting across the galaxy for uncountable ages, its fate shaped not only by gravity, but by the jitter of quantum fields. It was both vast and small, both stone and wave, both certain and uncertain. To study it was to confront the duality of reality itself, the marriage of Einstein's curved geometry with the indeterminate whispers of the quantum sea. Perhaps then, Atlas was not only a messenger of danger, but a reminder of humility, for even the largest stones in space are subject to the smallest uncertainties, and humanity, in its quest to know, remains caught between two incomplete visions of the universe, relativity and quantum mechanics, both true, both unfinished, both awaiting unification. In the anomalies of a wandering fragment, some hoped to glimpse the first cracks of that greater truth. As astronomers traced the projected path of 3I, Atlas deeper into the solar system, attention inevitably turned to the great guardian of our planetary family, Jupiter. The gas giant, swollen with mass more than twice that of all the other planets combined, has long served as both protector and threat. Its gravity is a shield, pulling countless comets and asteroids into its embrace before they can threaten Earth. Yet it is also a slingshot, hurling bodies inward at speeds greater than they ever possessed before. For Atlas, Jupiter loomed like a cosmic arbiter. Its gravitational field stretched far across space, bending the trajectory of interstellar wanderers in ways subtle yet profound. A near approach could mean capture, though unlikely. More often, it meant deflection, a redirection of fate that could send the fragment harmlessly outward or dangerously inward. Supercomputers modeled countless scenarios, each one tracing lines of possibility as Atlas swept past the giant's dominion. Some lines curved gently away, released back into the void. Others arced inward, drawn closer to the inner system, where Earth circled like a vulnerable jewel. The power of Jupiter to alter destiny is written into the history of the solar system itself. Without it, the inner planets might have been bombarded endlessly by comets, their surfaces too unstable for life to flourish. With it, the threat was reduced but never eliminated. The same gravity that shields can also endanger, amplifying small deviations into catastrophic intersections. For every comet it consumes, Jupiter also flings another sunward, like a bow casting arrows into the inner system. Atlas, moving at interstellar velocity, entered this field of influence with all the unpredictability of dice rolled against the stars. Astronomers spoke of Jupiter not as a planet, but as a gatekeeper, a cosmic sentinel whose decisions are impartial and absolute. If Atlas passed at just the wrong distance, the great planet's pull could magnify its slight irregularities, bending its course toward Earth in ways invisible until too late. Even a nudge of a few kilometers per second could alter its fate entirely. Gravity does not need to roar, it only needs to whisper, and time does the rest. Philosophers of science reflected on the symbolism. Jupiter, long worshipped as king of the gods, now stood as king of planetary fate. Its storms and stripes are familiar to telescopic eyes, yet its truest power lies in invisibility, the immense gravitational net it casts across space. Humanity owes its stability, perhaps even its existence, to this unseen guardian. Yet guardianship and menace are two faces of the same coin, and Atlas brought both to mind. In the public imagination, Jupiter became part of the drama. Artists rendered visions of the interstellar fragment sweeping past the giant planet, framed by its swirling clouds and great red spot. Commentators described the moment as a cosmic trial. Would Jupiter defend its smaller siblings, or would it, in its impartiality, unleash new danger? The reality was not one of intention but of chance. Yet chance itself felt heavy when the stakes were so vast. Thus, the gaze of astronomers settled on the giant. Every update of Atlas's position was measured against the gravitational contours Jupiter imposed. Every shift in its brightness, every uncertainty in its acceleration, was tested in simulations to see how the gatekeeper might respond. For in the end, the trajectory of a fragment from another star might hinge not only on its own nature, but on the silent tug of a world 400 million miles away. The fate of Earth, some realized, might depend on whether Jupiter chose, without choosing, to bend the interloper's path. Beyond Jupiter's realm lies another monument to celestial history, Saturn, with its ethereal rings spreading like a veil of ice and dust. If Jupiter is the solar system's guardian, Saturn is its archivist, a planet whose encircling rings are thought to be remnants of shattered moons or wayward comets, broken apart by gravity's relentless pull. To consider Atlas in relation to Saturn was to confront a different kind of reminder, that collisions are not rare accidents, but essential parts of planetary existence. Saturn's rings tell a story of destruction frozen into beauty. Each icy shard, each fragment of rock, is a relic of impact, torn from a larger body and held captive by gravity. To gaze upon them is to see the aftermath of cosmic violence, transformed into one of the most graceful spectacles in the sky. But that grace is fragile. The rings are dynamic, constantly shifting under Saturn's tides, their particles colliding and dispersing, their brightness a mask for chaos beneath. They are both shield and scar, proof that even worlds can be undone. Astronomers imagined Atlas sweeping near Saturn, not to be captured, but to feel the subtle touch of its gravity. Such an encounter would not be as decisive as with Jupiter, yet it would matter. Saturn's mass, though lesser, still bends trajectories across millions of kilometers. A near pass could alter Atlas's path just enough to shift probabilities, a reminder that destiny in space is not shaped by single events, but by accumulations of influence. Even the gentlest tug, amplified across distances, could set the fragment on a path closer to Earth. The rings themselves became a metaphor in this discussion. If Saturn's shattered remnants could persist for hundreds of millions of years, endlessly circling, then how many other collisions must have shaped the solar system unseen? How many Atlas-like wanderers had already passed, striking planets, breaking moons, seeding scars? Saturn's beauty was not a decoration but a warning. Creation and destruction are inseparable. What gleams in the telescope is also a graveyard. For planetary scientists, Saturn was more than poetry. Its rings provide data on the mechanics of fragmentation, on how bodies disintegrate under tidal stress. By studying them, they could model what might happen if Atlas were not a monolith, but a fragile body, liable to split under solar heating or gravitational strain. If fragments were released, each could follow its own course, multiplying the risks. Saturn's past destruction became a blueprint for what might unfold in the present. The symbolism extended further still. In myth, Saturn was a devourer, a god who consumed his own children to prevent being overthrown. In science, it devours too, not by swallowing whole, but by tearing apart what ventures too close. For Atlas, Saturn stood as both a reminder and a possibility, a planet whose rings speak endlessly of violence, whose gravity could shape the destiny of a stranger from another star. Thus, in the narrative of Atlas, Saturn was not a bystander. It was part of the chain of influence, another weight in the scales of chance. While Jupiter played the judge, Saturn played the historian, showing in its luminous bands what happens when celestial bodies meet their end. And in its quiet, spectral beauty, it whispered the truth that every world, even our own, carries within it the memory of collisions still to come. If Jupiter and Saturn acted as titans of gravity, shaping the flow of comets and asteroids across the solar system, then the true terror lay in what those slingshots could unleash. The mechanics of gravitational assists are well known. Spacecraft use them to steal momentum from planets, gaining speed without fuel. But the same law that allows human ingenuity to cross the stars also allows chance to hurl destruction inward. Astronomers studying Atlas ran simulations of near-planet encounters. If it passed close enough to a giant, the change could be profound. A slight bend in its trajectory might redirect it harmlessly outward, speeding it on its way beyond the Sunday. Yet another possibility, far more sinister, lurked among the outcomes. The object slung inward, deeper into the solar system, its path crossing the orbits of Mars, Earth, or Venus. In that scenario, the very guardianship of the outer planets became betrayal, turning defense into doom. The danger of gravitational slingshots was not hypothetical. Jupiter's pull is believed to have flung many comets sunward throughout history, some striking Earth with consequences carved into geology. It was the same mechanism that sent Shoemaker-Levy 9 crashing into Jupiter itself in 1994, a chain of impacts that left dark bruises on the planet's atmosphere and served as a stark reminder of celestial violence. The lesson was unmistakable. When giants bend trajectories, the results are spectacular and sometimes catastrophic. Atlas, moving at interstellar speeds, carried even greater unpredictability. Unlike long-period comets, whose orbits are centuries in the making, Atlas came as a single, unrepeatable encounter. Any gravitational nudge was irreversible. There would be no second chance, no long arc to refine predictions. Whatever deflection occurred would determine its fate and possibly ours. Scientists presented these outcomes in careful language, describing probabilities and ranges, emphasizing the safety implied by most simulations. But the unspoken truth pressed on them. Gravitational chaos is not neat. It is sensitive, volatile, and capable of magnifying the smallest uncertainties into catastrophic divergences. Atlas was not a stone gliding smoothly through space, but a pawn in a cosmic game where even the most subtle forces could alter destiny. For philosophers and poets, the metaphor was irresistible. Life itself seemed caught in a similar dynamic, fragile, sensitive, one random push away from transformation or destruction. Just as a comet could be slung toward doom by the indifferent pull of a planet, so too could civilizations be redirected by forces beyond their comprehension. Atlas became not only an object of science, but a parable of fate, a reminder that security is often illusion, that order depends on chance. The public imagination, too, seized on the imagery. Illustrations spread of Atlas whipping around Jupiter, streaking inward like a flaming spear aimed at Earth. Journalists spoke of cosmic billiards and celestial roulette, amplifying the tension. Though the probabilities were low, the imagery carried power, embedding itself in the cultural psyche. The idea that a planet's embrace could become a planet's betrayal struck a chord deeper than statistics could soothe. Thus, the concept of gravitational slingshots entered the narrative not as abstract mechanics, but as a visceral reminder. The very forces that protect can also endanger, and the giants of our system, impartial in their pull, offer no promises. Atlas might pass safely, its path bent outward to freedom, or, by the smallest chance, it might be turned inward, transformed from wanderer into weapon. The The difference between the two outcomes was measured not in certainty, but in whispers of probability, whispers heavy enough to haunt every sleepless night spent watching the sky. As Atlas drifted deeper into the sun's domain, astronomers turned their attention not only to planets, but to the star itself. For the sun is not merely a source of light, it is a restless furnace, exhaling storms of plasma, hurling waves of radiation, and extending its influence in every direction. The solar wind, though invisible to the human eye, is a constant gale sweeping across the system, carrying magnetic fields and charged particles that buffet everything in their path. For a small interstellar fragment like Atlas, these forces were not trivial. Radiation pressure, the faint but continuous push of photons, acted like an invisible hand, nudging its orbit ever so slightly. Outgassing triggered by solar heating might have been amplified by these pressures, turning tiny plumes into unpredictable accelerations. And then there were the coronal mass ejections, vast eruptions of solar plasma capable of flooding space with shock waves of particles. If Atlas encountered one at the wrong moment, its path could be altered in ways no model could foresee. The unpredictability of solar storms is notorious even for spacecraft built to withstand them. Satellites in Earth's orbit have been disabled, communications disrupted, power grids knocked down, all from the fury of a single solar event. For Atlas, there was no shield, no design, no preparation. Its surface was raw and vulnerable, its chemistry shaped by millions of years of cold. Now, in the sudden heat and tempest of the sun's breath, it might fracture, crumble, or accelerate in ways alien to our expectations. Astronomers watched carefully for signs. Did its brightness flicker in response to radiation bursts? Did its trajectory show faint deflections aligned with solar weather reports? Some anomalies appeared, but interpretation was murky. The sun's influence was real, but quantifying it remained maddeningly difficult. What could be said with certainty was this: Atlas was no longer moving through the silent void of interstellar space. It was in dialogue with a star, and that dialogue was unpredictable. The symbolism was profound. Humanity often imagines the sun as a giver of life, a warm constant in the sky. But for travelers like Atlas, the sun is both giver and destroyer. It strips comets of their icy shells, shatters asteroids under its heat, and drowns trajectories in storms of radiation. It is a reminder that stars are not benevolent, they are violent, indifferent, and dangerous. Atlas, in entering the sun's domain, had entered a crucible. For scientists, this was also an opportunity. If fragments did break from Atlas, their trails could reveal composition otherwise hidden. If radiation pushed it off course, the degree of deviation might teach us about its mass and density. Even in danger, there was knowledge to be gained. The challenge lay in separating what was signal from what was chaos, in teasing meaning from a conversation written in the unpredictable language of plasma and light. For philosophers, the thought was darker. The sun, which sustains all life on Earth, might in the end be the force that turns a harmless wanderer into a weapon. A solar storm at the wrong time could tilt ATLAS's trajectory just enough to bring devastation. The same star that nurtures could betray, not by intention, but by indifference. Thus, the presence of the sun in Atlas's journey reminded humanity of another truth. Survival depends not only on planets and gravity, but on the whims of a star. And in those whims lies the most ancient lesson of all, that the cosmos does not care for us, that life is fragile, and that every dawn hides the possibility of catastrophe. As telescopes tracked the interstellar wanderer, another question surfaced: was Atlas truly alone? For many comets and asteroids, solitary travel is an illusion. They often carry companions, fragments that have broken off, clouds of dust trailing invisibly, or debris fields that orbit faintly around them like spectral attendants. If Atlas had companions, even small ones, the implications multiplied. Searches began in earnest. Wide-field surveys swept the skies around its path, looking for faint smudges of light, secondary points moving in lockstep with the main body. Some astronomers suspected that its unusual brightening might not be the result of a single intact nucleus, but of fragmentation pieces already splintering away, each following its own subtle orbit. If so, then Atlas was not one threat, but many, a train of shards strung invisibly across the solar system. The dangers of such fragments are not hypothetical. History offers grim examples. Comet Shoemaker-Levy 9 broke apart into a chain of pieces before slamming into Jupiter in 1994, each fragment leaving scars larger than Earth itself in the giant's atmosphere. Other comets, too, have disintegrated silently, their debris spreading into trails that intersect with planets. To encounter such a trail is to face not one impact, but many, raining destruction across wide regions of a world. For Earth, the possibility was chilling. Even a fragment only tens of meters wide could release energies rivaling nuclear weapons if it struck at interstellar speeds. A cloud of such pieces, unseen until too late, could deliver devastation not as a single apocalyptic strike, but as a sequence of regional catastrophes. Cities might vanish in fireballs, coastlines torn by tsunamis, skies filled with smoke and ash. The randomness of such a scenario made it all the more terrifying. Telescopes strained to catch any signs. Some claimed faint detections, small anomalies of light beside the main body. Others argued these were illusions, noise in the data. The debate carried urgency, for the presence of fragments would alter orbital predictions dramatically. Each shard would respond differently to radiation, gravity, and solar wind. The more fragments existed, the greater the uncertainty became. Atlas would not be a single trajectory, but a swarm, each member carrying its own possibilities. The symbolism was unsettling. A lone wanderer was fear enough a messenger from another star, indifferent and immense. But a company of wanderers suggested something darker, that destruction might not come in one blow, but in many. That the universe does not always strike cleanly, but in patterns of shattering, scattering chaos. Scientists continued to monitor, but certainty proved elusive. The visitor's faintness, its speed, and its distance conspired to keep its secrets hidden. Yet the suspicion remained, hovering like a shadow, that Atlas might not travel alone. And if it did not, then humanity faced not merely one riddle in the sky, but many each fragment, a reminder that the cosmos is less ordered than we hope, more dangerous than we admit, and far less forgiving than we dare to believe. The search for clarity demanded vigilance. Around the world, observatories turned their instruments toward Atlas, each night adding new data points to the fragile web of knowledge. From the volcanic peaks of Mauna Kea to the high deserts of Chile, from robotic telescopes scattered across the southern hemisphere to amateur astronomers with precise backyard equipment, a global effort unfolded. The object was faint, fleeting, and fast. Every clear night was precious, every exposure a chance to pin down its secrets before it slipped once more into invisibility. Astronomers coordinated like sentinels keeping watch. Data was pooled across continents, light curves compared, orbital refinements exchanged. Networks, such as the Minor Planet Center, became nerve centers of information, publishing updates with urgency, each bulletin a fragment of truth to be fitted into the puzzle. The atmosphere in these communities was one of shared vigilance, a recognition that no single observatory could shoulder the task alone. Humanity had to watch together, or not at all. Night after night, Atlas drifted across starfields. Its faint glow tested the limits of instrumentation, often requiring long exposures and painstaking processing. Spectrographs strained to capture its light, revealing little beyond hints of dust and faint traces of volatiles. Radar attempts were made, but its distance and velocity rendered echoes scarce, too weak to carve a clear picture. Each technique wrestled with the same obstacle: time. The visitor was moving too quickly, fading too rapidly, and the window of observation was closing. Despite the limits, progress came. More precise measurements narrowed its estimated size to less than a kilometer, perhaps only a few hundred meters. Light curves suggested an irregular shape, tumbling unpredictably, reflecting sunlight in flashes that complicated calculations. These details, though modest, mattered greatly. Size determined destructive potential, rotation influenced fragmentation, and shape hinted at its violent past. Each number gleaned was another step toward understanding what this wanderer truly was. Yet the act of watching was not without tension. Every new data point brought with it both comfort and unease. Comfort, because probabilities of impact seemed to shrink with refinement. Unease, because anomalies persisted, refusing to vanish entirely. Astronomers kept their tone cautious in public, stressing the safety of the most likely outcomes. Privately, some admitted the frustration of chasing certainty that never quite arrived. To observe Atlas was to stand at the edge of knowledge, staring into a fog where clarity receded as quickly as it appeared. And so the vigil continued. Observatories logged their nights, papers drafted their cautious analyses, instruments strained against the limits of sensitivity. But beneath the technical process lay something older, a human instinct of watchfulness. It was the same vigilance our ancestors once carried when they scanned the horizon for storms or enemies, when they studied the night sky for omens. Atlas had become, in essence, a new kind of fire on the horizon, a faint, distant glow that demanded attention, not because it was certain to harm, but because it could. Behind the observatories and research papers, whispers moved quietly through the halls of space agencies. At NASA, at ESA, and within other organizations tasked with planetary defense, the arrival of 3I, Atlas was more than an astronomical curiosity. It was a test of readiness. Officially, the risk was low. Press briefings emphasized caution, not alarm. But behind closed doors, engineers and strategists weighed darker possibilities. For decades, humanity had studied ways to defend itself against near-Earth objects. Projects like NASA's Planetary Defense Coordination Office existed precisely for such scenarios. Yet most plans assumed local asteroids or comets, bodies with orbits predictable decades or centuries in advance. Atlas was different, a stranger from another star, crossing our system only once, at speeds beyond the norm. If it were to strike, the warning time would be terrifyingly short, and the tools humanity had developed might not be enough. At meetings, scenarios were discussed in careful language. Could a kinetic impactor, a spacecraft designed to ram an asteroid, alter the path of an interstellar body? Possibly, but the velocity of Atlas meant the required energy would be orders of magnitude greater than any mission ever attempted. Could nuclear devices be used as a last resort, detonated nearby to push the object off course? Theoretically, yes, but political and ethical constraints loomed large, and the effectiveness against a fast, tumbling body was uncertain. Even the most optimistic timelines showed how little time humanity truly had. Some voices argued that even attempting deflection was futile. The best hope, they suggested, was observation and preparation, knowing as early as possible if impact were certain, so that humanity could brace for consequences. Others countered that resignation was unacceptable. To do nothing was to accept vulnerability, to surrender before the threat even materialized. Between these poles, agencies found themselves trapped, compelled to prepare, but without the means to guarantee survival. The tension extended beyond technical debate. Political advisors began drafting contingency plans. what to say if probabilities shifted, how to prevent panic, how to maintain stability if the unthinkable grew likely. Public imagination was already stirring, fueled by rumors and headlines. Governments could not afford silence, but neither could they afford terror. Atlas became not just a scientific object, but a test of communication, trust, and the delicate balance between truth and fear. Among scientists themselves, the whispers carried a different weight. Many confessed that their unease was not only about planetary defense, but about what Atlas symbolized. It was proof that the universe could deliver threats from directions humanity had never prepared for. Local asteroids could be mapped and catalogued. Interstellar objects arrived unannounced. It was as though the cosmos had reminded us that vigilance, however advanced, would never be complete. Thus, the agencies watched. They issued cautious updates, avoided words like danger, and pressed for more telescope time. Yet, behind the composure lay a quiet urgency. For though the chances were low, the consequences were absolute. And in that fragile balance between probability and catastrophe, humanity's planetary defense infrastructure found itself weighed, measured, and, perhaps, found wanting. Even as official statements kept their language measured, a parallel current of speculation ran through scientific circles and the public alike. For whenever the unknown presses too closely against the familiar, imaginations rush to fill the gaps. And with 3i, Atlas, the gaps were wide. Some astronomers, recalling the lingering enigmas of Oumuamua, wondered aloud, though never in formal papers, if Atlas might be more than inert rock or ice. The idea of artificial origin, of technology adrift in the galaxy, returned like an echo. Could its irregular brightening, its unpredictable accelerations, be signs not of natural forces but of structure, a thin shell, a hollow body, a fragment of something once engineered? Most dismissed the thought as improbable, but the very fact that it was discussed at all revealed the unease. Theories multiplied in the public sphere, where restraint was looser. Writers compared Atlas to a derelict probe, a vessel cast from a civilization long dead, wandering endlessly between stars. Others speculated about alien sails, vast sheets, once driven by starlight, now tattered relics drifting on. More extravagant voices suggested it was a seed, an artifact placed deliberately to travel, a carrier of knowledge or destruction. To most scientists, these ideas were fanciful, but they spread quickly through media, gaining life beyond data. The danger in such theories was not only that they lacked evidence, but that they blurred into fear. For if Atlas were artificial, then its trajectory toward the inner solar system took on ominous tones. Was it merely passing, or was its path deliberate? Was its silence indifference or intent? Questions that science could not answer became fuel for cultural anxiety. The unknown was no longer just a rock, it became a mirror for human dread of the other. Yet some scientists defended the value of speculation. To dismiss exotic ideas entirely, they argued, was to ignore history. Many great discoveries had once seemed impossible, absurd, or unthinkable. To imagine Atlas as more than natural was not to declare it so, but to stretch the boundaries of inquiry. If we do not at least ask, one theorist wrote privately, we risk being unprepared for answers stranger than our expectations. In the end, the exotic theories remain just that: whispers, possibilities, stories hovering at the edge of data. But their persistence revealed something profound, that interstellar visitors carry not only mass and momentum, but meaning. They awaken in us the realization that the universe is vaster than our categories, and that some fragments may bear mysteries, not reducible to ice, rock, or dust. Atlas thus became more than a celestial body. It became a screen upon which humanity projected its deepest fears and fascinations: alien probes, ancient technologies, forgotten civilizations. Perhaps it was none of these. perhaps only a fragment of shattered ice. But in the absence of certainty, the imagination filled the silence, reminding us that science and myth often grow from the same soil of wonder and dread. Beyond speculation of alien craft or shattered worlds, another force entered the discussion, a force not born of material fragments, but of the cosmos itself. Some theorists asked whether 3I, Atlas, might be subtly influenced by dark energy, the mysterious driver of the universe's accelerating expansion. On galactic scales, dark energy shapes the very destiny of the cosmos, pushing galaxies apart with invisible hands. Yet its presence is undetectable in ordinary life, unmeasurable within our solar system, or so it was believed. But Atlas, moving at interstellar speeds through millions of years of emptiness, raised the question anew: could the faint, cumulative tug of dark energy alter the course of such wanderers in ways too delicate to perceive until they brushed against the gravity of our sun? The idea was provocative. If true, it might explain why Atlas, like Oumuamua before it, seemed to defy precise orbital prediction. Perhaps its path carried with it the imprint of expansion itself, a subtle drift encoded over its vast journey across the galaxy. Some suggested that the faint anomalies in its motion were not outgassing or error, but the whisper of cosmology intruding into local space, a reminder that even stones can be messengers of the universe's deepest laws. Others took the speculation further. If dark energy could influence an interstellar fragment, then every such object arriving in the solar system was not only a visitor, but a data point. By studying their orbits in detail, humanity might one day measure the immeasurable, glimpse the fingerprints of the cosmos's expansion written onto the trajectories of alien debris. Atlas might then be not a threat, but an experiment delivered by chance, a natural probe of forces that no human instrument could otherwise test. Skeptics dismissed the notion. The accelerations caused by dark energy on such scales were infinitesimal, far smaller than what telescopes could resolve. The anomalies in Atlas's orbit were more easily explained by jets of gas, irregular shape, or measurement noise. To invoke dark energy, they argued, was to chase shadows. But even skeptics admitted that the thought had a certain poetry. To imagine a fragment of stone carrying within its path the signature of the universe's fate was to stretch the imagination beyond craters and collisions into the fabric of existence itself. For philosophers, this idea resonated. Atlas became a metaphor of connectivity, the notion that even a small object tumbling silently through the void was bound to the same force that drives galaxies apart. To study it was to see in miniature the expansion of the universe, to confront the reality that nothing, not even a lonely rock, is exempt from the influence of the infinite. Thus, dark energy entered the narrative not as proof, but as possibility. Atlas was no longer only a stone, a threat, or a relic. It was also a question: could the grandest forces of the cosmos leave traces on the smallest of wanderers? And if so, what else might such objects reveal, arriving unannounced at the doorstep of our solar system, carrying with them not just danger, but the fingerprints of the universe itself? As the debates over gravity, radiation, and dark energy swirled, a deeper question began to surface, one that no telescope could resolve. What did 3I, Atlas, mean for humanity's understanding of itself? Science had done its work, gathering data, calculating trajectories, framing probabilities. Yet beneath the mathematics lay an unease that was not purely scientific. It was existential. For centuries, humanity has sought stability in the heavens. The stars were fixed, the planets predictable, the cosmos a grand clockwork whose order reassured as much as it humbled. But each interstellar visitor cracked that illusion. Oumuamua had shown that strangers could arrive without warning. Borisov had shown that such visitors might carry alien chemistries. And now Atlas showed that some travelers might resist even our most rigorous attempts at classification. The universe, once thought steady, revealed itself as restless, volatile, and indifferent. Philosophers likened Atlas to a mirror. In it, humanity saw not only the possibility of destruction, but the fragility of certainty. If a single rock from another star could shake the confidence of physics, what did that say of our place in the cosmos? If probabilities of extinction, however small, could never be reduced to zero, what did that say of the permanence of civilization? The object was less a threat than a reminder that survival has always been contingent, that knowledge has always been incomplete. For the public, Atlas became a vessel for imagination. Some saw in it doom, others wonder. It was painted in art as both spear and messenger, as omen and gift. Stories blossomed, not of data, but of meaning, of what it means to live in a universe where stones from alien suns can appear without warning, carrying within them both knowledge and the possibility of erasure. The scientific community, though cautious, could not entirely resist this current. For even within the language of equations, awe is unavoidable. And so Atlas forced a philosophical reckoning. Humanity was reminded that the cosmos is not built for our comfort. It is not designed to be understood, nor to guarantee our survival. It is vast, restless, and indifferent. Yet in that indifference lies meaning, not in the promise of safety, but in the challenge of awareness. To live under such skies is to accept fragility, and to find wonder not in permanence, but in persistence. Atlas, then, was not just a fragment from another system. It was a lesson that uncertainty is inescapable, that improbability still carries weight, and that knowledge, however advanced, will never erase mystery. In its passage, humanity glimpsed not only a stone from beyond, but a truth about itself, that to exist at all in a universe so full of hazards is both a miracle and a question. The march of discovery pressed forward, and with it came sharper eyes. Humanity had just begun to wield a new generation of instruments, the James Webb Space Telescope, poised at L2 like a lantern beyond the moon's glare, and the still preparing Vera Rubin Observatory, with its vast mirror designed to map the changing sky in nightly sweeps. For astronomers, these telescopes represented more than technological triumphs. They were weapons of clarity, aimed at the mysteries that had haunted Oumuamua and now cloaked 3I. Atlas, Webb, with its infrared gaze, promised to strip away the faintness that had veiled so much of the object's character. Where optical telescopes saw only dim reflected sunlight, Webb could read the heat it emitted, measure its temperature, and infer its composition. Was it covered in alien ices, slowly sublimating under the sun's light? Did it conceal metallic elements, remnants of a shattered planetary core? By passing the faintest photons, Webb could transform a smudge into a portrait. The Rubin Observatory offered a different gift. Time itself, with its wide field of view and relentless cadence, Rubin was designed to track the shifting heavens night after night, creating a living atlas of change. For Atlas, whose trajectory defied easy prediction, such continuous monitoring was invaluable. Small deviations in brightness, erratic flickers in rotation, subtle curves in its path. Rubin's eyes could capture them all, feeding data into models desperate for refinement. The collaboration between these instruments was a glimpse of the future. For centuries, astronomy had been reactive, catching what chance delivered. Now, humanity wielded telescopes capable of anticipating, of not merely seeing, but interpreting in real time. Atlas was the test case, the visitor that arrived just as humanity's vision sharpened. It was as though the universe had chosen its timing, sending a messenger when we were finally able to read it more clearly. And yet, the promise was shadowed by unease. What if Webb's spectra revealed chemistry unlike anything known, molecules alien to our solar system? What if Rubin's relentless data stream confirmed that the anomalies were real, not errors, not noise? The sharper the eyes, the deeper the dread. For clarity does not always bring comfort. It can also bring revelation that unsettles the very ground of knowledge. Astronomers prepared nonetheless. Observing time was requested, schedules rearranged, instruments calibrated. In those decisions lay urgency. Atlas was fleeting, moving too quickly to linger. The opportunity would not return. Each night lost to clouds or technical faults was a page of the story left unread. Humanity had waited billions of years for such encounters, and now it had tools equal to the challenge. To miss the chance was unthinkable. Thus, the new telescopes became symbols not only of progress, but of responsibility. Atlas demanded that humanity look deeper, faster, more honestly. It was a test not of instruments alone, but of will. Would we dare to see what it truly was, even if the answer shook our sense of safety? The eyes were open. The question was whether we were prepared for what they might behold. If the great eyes in space sought to unveil 3I, Atlas in the infrared, another tool offered a different kind of gaze, radar. On Earth, massive radio antennas, Arecibo once, now gone, Goldstone still, networks across the globe had long been used to ping nearby asteroids, bouncing signals off their surfaces and listening for the faint echoes. From those returning whispers, shapes could be mapped, rotations measured, surfaces glimpsed in ghostly detail. For Atlas, radar promised something no optical telescope could give, a direct touch, a handshake of radio waves across millions of kilometers. The challenge, however, was immense. Atlas moved faster than any local asteroid, its distance growing with each passing night. Radar beams spread and weaken with distance, their echoes fading into the background noise of the universe. To catch a reflection from something so small, so swift, required exquisite timing and enormous power. Goldstone's dishes tilted skyward, engineers calculating the moment when Atlas would pass within reach of their signals. The experiment was as daring as it was delicate, one chance, perhaps two, before the visitor sped forever out of range. The attempt carried suspense. If radar succeeded, the reward would be extraordinary. Even the faintest echoes could sketch its outline, reveal whether it was elongated like Oumuamua or fractured like Shoemaker, Levy's chain. Radar could show if its spin was chaotic, if its surface was rough or smooth, if it was solid or perhaps already breaking apart. For a body from another star, such data would be priceless, a three-dimensional glimpse of something born under alien light. Scientists prepared like surgeons before an operation. Algorithms were refined, noise reduced, data pipelines tested. They knew the chances of failure were high. The object was faint, the range punishing, but they also knew that without radar, much would remain speculation. To send a pulse of radio waves toward Atlas was to demand an answer from the void, however faint, however fleeting. Even if no echo returned, the act itself carried meaning. Humanity was reaching outward, trying to touch what the cosmos had sent, to claim more than photons reflected by chance. It was an extension of the same instinct that once drove seafarers to cast lines into the deep, hoping to feel what swam beneath unseen waves. Radar was a line thrown into the cosmic ocean, daring to tug back something solid. For those involved, the symbolism was undeniable. To bounce signals off an interstellar object was to bridge distance not only in space, but in history. Never before had humans directly touched something born under another sun. Atlas, indifferent and silent, would not know it was being measured, but humanity would know. And in knowing, we would cross another threshold, from passive observers of interstellar fragments to participants in their study. Whether the echoes came back or not, the attempt underscored a deeper truth that in the face of uncertainty, humanity chooses not only to fear, but to reach. Atlas, in its fleeting passage, had forced us to extend ourselves, to try to grasp what passes so quickly through the sky. And in that reach lay not just science, but the very essence of survival. Radar was not the only thread humanity cast into the night. Across the Earth, astronomers pooled their resources into one of the most ambitious collaborations ever attempted, a worldwide network of observatories, synchronized not just in purpose, but in heartbeat. It was a dance of telescopes, each waiting its turn as the planet rotated, ensuring that Atlas would never slip from the gaze of human eyes. This global coordination carried echoes of the old International Geophysical Year, when nations once joined to measure the Earth and the sky together. But now the stakes were larger. Atlas did not linger, it raced. Every hour lost meant lost detail, lost precision, lost certainty. To counter that, the European Southern Observatory, Keck in Hawaii, the Vera Rubin Observatory preparing to scan the heavens, even smaller university telescopes, all were called upon, each adding a stitch to the fabric of continuous observation. Together, they wove a portrait that no single eye could see. Europe caught Atlas before dawn, handing the thread to the Americas as day broke, which then passed it westward to Asia and Australia. The pattern was seamless, a chorus of instruments singing in different wavelengths but harmonized in intent. Photometry revealed its flickering light curve. Spectroscopy traced the whisper of elements. Adaptive optics sharpened what turbulence blurred. It was less one telescope watching, more a planet leaning forward in unison, unwilling to let the visitor escape unseen. The data streamed across networks at the speed of light. Servers filled with gigabytes of starlight transformed into numbers, models, simulations. In universities and research centers, graduate students pulled long nights, feeding data into software that spun predictions, trajectory refinements, spin analysis, thermal models. It was frenetic, exhilarating, desperate, a race not against another country, but against the very rotation of the Earth and the fleeting nature of the cosmos. And yet, in this unity, there was also fragility. Clouds over Chile could erase a vital sequence. A power outage in South Africa could sever a link. Politics still loomed, budgets still constrained, and some observatories resisted sharing raw data. But the urgency of Atlas bent many wills. Rivalries softened, secrecy gave way to cooperation. It was as though the object itself, indifferent as it was, compelled humans to rise above their divisions, if only briefly. For the scientists on the ground, there was awe as well as urgency. They knew that they were living through a moment that future textbooks would recount the first time humanity tracked, in real time and as one species, the passage of an interstellar wanderer whose future might one day intersect dangerously with our own. They were witnesses, but also stewards, guardians of memory. Every photon caught was a reminder. The universe was watching us too, measuring what kind of beings we chose to be when faced with mystery. And so, as the telescopes hummed and the data surged, Atlas became more than an object. It became a mirror of humanity's highest capacity to coordinate, to collaborate, to refuse to let the unknown pass unchallenged. For a brief span, the divisions of the Earth blurred, and what remained was a singular focus. Hold the gaze of the stranger from the stars, no matter the cost, until it was gone. If radar and telescopes offered humanity's eyes and hands, spacecraft promised its stride. The thought emerged almost immediately after Atlas was identified. Could we reach it? Could a probe, hastily designed or cleverly repurposed, chase down the interstellar wanderer before it slipped away forever? On paper, the idea sounded impossible. Atlas raced through the solar system at tens of kilometers per second, its path angled steeply relative to the ecliptic. To match its velocity, or even to intercept briefly, required a monumental burn of fuel, a trajectory more extreme than any mission yet flown. Traditional rockets could not hope to keep pace. And yet, daring minds began sketching. At NASA, ESA, and in smaller private companies, engineers whispered of audacious concepts: solar sails that could be deployed within months, ion thrusters pushed to their limits, gravity assists strung together like a celestial slingshot. For many, the dream was not to land, but to rendezvous, to swing close enough to photograph, to analyze spectra up close, to perhaps fire a dust collector into its tail if it bore one. Even a flyby would be transformative. To see, in detail, an object forged around another star was to glimpse geology alien to our own, chemistry sculpted in another nursery of light. But dreams collided with reality. Launch windows were vanishingly tight. Every day lost meant the target receded further. Budgets constrained what could be attempted. A mission fast-tracked would risk failures. Spacecraft cobbled in haste could end up silent in the void. Still, the proposals piled up. Project Lyra, drafted by the Initiative for Interstellar Studies, suggested high-energy trajectories or solar Oberth maneuvers, swooping perilously close to the Sun to gain speed. Others invoked the possibility of nuclear propulsion, ideas long shelved but suddenly resurrected by urgency. The debates turned philosophical. Was it worth billions for a chance encounter? Would humanity ever again see such an opportunity? Or was Atlas merely the first of many? Some argued we should focus on planetary defense, not romantic pursuits of cosmic visitors. Others countered that to miss this chance was to deny ourselves knowledge of the wider galaxy, to remain provincial in a cosmos that had just knocked on our door. Even without a mission, simulations flourished. Virtual spacecraft were sent in models, their trajectories tested, their encounters visualized. Artists painted renderings of sleek probes racing against the backdrop of stars, reaching out toward the faint blur of Atlas. It was imagination as rehearsal, a way of preparing humanity for the day when such missions would no longer be optional, but necessary. And beneath the debate lingered the darker thought. If Atlas or its kin ever approached too close, we would not be sending probes to study, we would be sending missiles to defend. Spacecraft, whether instruments of curiosity or guardians of survival, would become humanity's front line. Atlas was rehearsal not just for wonder, but for existential responsibility. Thus, the question of spacecraft was left unresolved, suspended between hope and limitation. Humanity's hands were not yet swift enough to grasp the fleeting visitor. But the vision lingered, and with it a quiet vow. The next time the stars sent a messenger, we would be ready to meet it not only with our gaze, but with our reach. While spacecraft engineers debated the possible and the impossible, another force rose quietly behind the telescopes and observatories: the machines of learning themselves. Artificial intelligence, long trained on patterns of finance, language, and image, was now turned toward the faint, flickering signals of Atlas. The data it generated, light curves, spectral lines, positional shifts, was too vast and too nuanced for human eyes alone. AI became the interpreter, the silent mathematician who never slept. Neural networks devoured terabytes of observational data, comparing Atlas's brightness variations to millions of simulated bodies, tumbling cylinders, fractured shards, elongated ellipsoids, even loose rubble piles spinning like clouds of stone. Within weeks, the algorithms narrowed possibilities that would have taken humans years to explore. What once seemed ambiguous now sharpened into likelihoods. The spin axis tilted at an improbable angle, the surface darker than anticipated, the light curve hinting at asymmetry, perhaps an uneven outgassing. perhaps fractured geometry. Yet, even as it clarified, AI unsettled. Its models suggested subtle accelerations unexplained by gravity alone. The echoes of Oumuamua returned. Had we stumbled once again upon an object whose motion betrayed secrets? Was this outgassing, or was it something our physics had yet to name? The algorithms did not answer. They only pointed to anomalies, patterns invisible to unaided eyes, leaving humans to confront the mystery anew. The machines also forecast trajectories with terrifying precision. By ingesting streams of updated orbital data, they plotted countless futures for Atlas, each line a thread weaving through the solar system. Most paths bent harmlessly outward, a sling past the sun and into interstellar dark. But a small cluster of simulations brushed closer to Earth, closer than was comfortable. Statistically improbable, yes. Impossible, no. In this, the AI became less a tool than a prophet. Its cold predictions forced humanity to reckon with probabilities of catastrophe, however remote. Governments demanded daily updates. Defense agencies scrutinized plots that curved too near. For the first time, the fate of an interstellar object became not just the concern of scientists, but of generals and ministers. Philosophers, too, weighed in. Was it right to entrust our interpretation of the cosmos to algorithms? Did AI reveal truth, or only a mirror of the assumptions fed into it? If an interstellar object truly veered toward us, would humanity accept that knowledge, or dismiss it as computational paranoia until the sky itself confirmed? Still, the alliance of human and machine grew. Astronomers and AI together sculpted meaning from noise, weaving narrative from numbers. Atlas was no longer a blur of light, but a data-rich tapestry, decoded at a pace impossible without silicon minds. And in the process, another truth emerged. The future of cosmic discovery was no longer purely human. It was hybrid, a partnership where intuition and pattern recognition interlaced. As Atlas continued its arc, the role of AI shifted from passive analysis to active prediction. It whispered futures, some serene, some catastrophic, all demanding attention. And in its impartiality, it forced humanity to confront its own biases, the desire to hope, the instinct to fear, the reluctance to imagine doom. Atlas, through the lens of artificial intelligence, became more than an interstellar visitor. It became a test of whether humanity could bear the cold mirror of probability without flinching. As the weeks unfolded, the world beyond laboratories and observatories began to stir. News of Atlas, once confined to scientific journals and hushed conference calls, spilled into the wider current of public discourse. Headlines painted it in shifting colors: the visitor from beyond, a harbinger from the stars, a possible threat to Earth. Each outlet chose its own metaphor, each nation its own tone. What scientists viewed as probabilities, the public received as prophecy. Television anchors framed it against the backdrop of cinema. Talk shows compared it to the asteroid of Hollywood nightmares. Debates swirled over whether it was humanity's first real rehearsal for apocalypse. Social media lit with speculation, memes transforming the object into a symbol of either doom or destiny. Hashtags surged: number Atlas visitor, number interstellar messenger, number cosmic threat. For a public weary of terrestrial crises, the story of something alien, vast, and uncontrollable became both distraction and obsession. Governments, too, could not remain silent. Press conferences attempted calm tones, emphasizing that the probability of impact remained vanishingly small, yet the very need for reassurance betrayed unease. Defense ministers briefed parliaments. Space agencies found themselves summoned to assemblies, and in some nations, leaders subtly invoked Atlas as justification for accelerated funding of space defense programs. The interstellar object, though innocent, had already been conscripted into human geopolitics. Religions responded with equal fervor. Some called Atlas a sign, a messenger of divine intention, a reminder of human frailty before the vastness of creation. Preachers spoke of it as an omen, while mystics saw in its path symbols of cosmic alignment. To many, it was not a rock at all, but a metaphor writ across the heavens. The human mind, unable to rest with silence, sought story, meaning, pattern. Atlas provided the canvas. Meanwhile, voices of caution rose from scientists themselves. They warned against sensationalism, urged patience, reminded the world that wonder need not always be cloaked in fear. But their voices often drowned in the louder rhythm of panic and spectacle. Humanity had always been a species of storytellers, and Atlas, whether danger or not, had become the story of its time. In classrooms, teachers used the object to awaken curiosity. Students sketching orbital diagrams, imagining journeys across stars. In markets, books and films pivoted to capture the wave of fascination. Entrepreneurs sold trinkets modeled after its trajectory, T-shirts that read, "I survived Atlas 2030. Even as scientists worked, culture consumed, reshaped, and commodified. And beneath it all lay a subtle shift. Humanity was, for the first time, collectively aware of its vulnerability to the wider galaxy. The illusion that space was distant, empty, and irrelevant faltered. Atlas had torn the veil, reminding billions that the cosmos was not a backdrop, but a participant in human fate. Thus, the object lived a double life. In the sky, a fragment of stone or ice sweeping indifferently past the sun. On Earth, a mirror reflecting humanity's anxieties, hopes, and divisions. Atlas did not choose this role, but humanity, restless in meaning-making, could not help but cast it as both menace and muse. The voices of governments grew sharper as Atlas climbed higher in the public imagination. Closed-door sessions of national security councils weighed its trajectory, not just in scientific probabilities, but in military terms. Could an interstellar object be weaponized? Could rivals exploit the panic for leverage? In a world accustomed to suspicion, even the silent path of a cosmic wanderer became fuel for earthly rivalry. In the United States, congressional hearings demanded answers from NASA and the Pentagon alike. The same officials who once defended budgets for planetary defense against near-Earth asteroids now spoke of Atlas as if it were both a threat and an opportunity. Funds were reallocated, research accelerated, missile defense programs scrutinized for their adaptability to the sky. Across the Atlantic, European ministers convened emergency panels, balancing scientific transparency against the instinct for secrecy. In China and Russia, the calculus was different but no less urgent. Could they afford to be seen as less prepared than their rivals? Thus, in the shadow of a fragment from another star, new alliances and new frictions surfaced. On one hand, calls for a coordinated planetary defense initiative gained momentum. Proposals circulated for shared early warning systems, international task forces, even joint missions. On the other, mistrust simmered. Would shared data reveal technological capacities one nation preferred to keep hidden? Would collaboration weaken sovereignty? Atlas forced nations into a paradox. Unity was the only logical path, yet suspicion was the oldest instinct. The United Nations attempted to mediate. Its Office for Outer Space Affairs organized briefings, urging calm, urging cooperation. Draft resolutions called for transparency, the open release of orbital data, and a renewed framework for dealing with cosmic hazards. Yet in the halls of diplomacy, the object itself became secondary. What mattered was posture, appearance, leverage. Some leaders spoke of humanity's shared destiny, others saw only negotiation chips. Meanwhile, defense industries quietly flourished. Companies that had long lobbied for asteroid deflection systems suddenly found receptive ears. Contracts expanded for kinetic interceptors, nuclear propulsion studies, and advanced tracking systems. To engineers, Atlas was a case study. To executives, a market surge. What was, in truth, a passing visitor from interstellar space had become an economic engine, reshaping budgets and priorities. And still, amid the noise of politics and profit, a quieter truth glimmered. Humanity's arguments, its mistrust and ambition, were all but invisible from the vantage of the object itself. Atlas swept along its orbital arc, untouched by declarations, immune to treaties. To it, Earth was only another gravitational encounter, a blue sphere it would skim before vanishing into darkness again. But for humanity, its presence was a rehearsal of science, yes, but also of diplomacy, fear, and trust. In this way, Atlas revealed not only the fragility of planetary defense, but the fragility of human unity. It was a test humanity had written for itself, disguised as a stone from another star. And whether it passed or failed would echo long after the visitor was gone. While governments and militaries postured, the quieter domain of academia remained a steady current, probing Atlas with questions that reached beyond immediate threat. For scientists, it was not enough to know whether the visitor was dangerous. They wanted to know what it was, where it came from, and why it moved the way it did. And in the quest for answers, ancient theories stirred with renewed life. At Harvard, Avi Loeb revisited arguments he had once raised about Oumuamua, suggesting again that such an object might not be merely natural. He cautioned that Atlas's anomalous accelerations, if confirmed, could hint at phenomena our physics did not yet contain, or even at the residue of technology. Most dismissed the thought as sensational, but even those who disagreed admitted the anomalies needed explaining. Others turned to the expanding body of research on interstellar planetesimals, arguing that Atlas was proof of what had long been theorized, that planetary systems shed debris endlessly into the galaxy. Fragments cast adrift across light years until gravity captured them briefly in alien skies. Some theorists asked if Atlas had crossed paths with dark matter clouds, its motions subtly warped by the invisible fabric of the cosmos. Others whispered of false vacuum decay, quantum instabilities that might ripple space-time in ways not yet imagined. Was Atlas an accident, or a messenger carrying with it traces of conditions in a different stellar nursery, a sliver of chemical memory from another sun's creation? The academic debate unfolded not only in journals, but in midnight symposiums streamed across the world. Graduate students challenged professors, data analysts sparred with theoreticians, and the tone was often less defensive than exhilarated. For once, humanity had something genuinely new, something not explained away by textbooks, not domesticated by precedent. Atlas was a raw question, unpolished and alive. The anomaly of its motion became a focal point. Was the slight deviation due to outgassing, like a comet? Yet telescopes found no significant tail, no plume of sublimating ice. Was it radiation pressure from the sun, nudging a thin, flat body? That seemed improbable, but not impossible. Each possibility carried implications. If outgassing, what exotic ices lay within? If radiation pressure, what material could be so light, so reflective, so alien? Beyond the data, the philosophers of science found their own playground. Atlas was not just a puzzle, it was a reminder of epistemic humility. The universe was under no obligation to fit neatly within our categories of asteroid or comet, rock or ice, natural or artificial. It could be something else entirely, a third category for which we had no word yet. And in confronting that, scientists were forced to admit discovery is not the confirmation of what we expect, but the eruption of what we cannot name. The public rarely followed these debates in their nuance. To most, Atlas was either harmless or threatening, natural or artificial. But within academia, the visitor carved space for something rarer, the possibility of being wrong, of needing to rethink. And that, for the community of discovery, was perhaps the most valuable gift the interstellar stranger could bring. As Atlas moved steadily along its orbit, humanity's fascination was not confined to data streams and academic halls. Culture, ever hungry for symbols, absorbed the interstellar visitor into its bloodstream. In music, in film, in literature, Atlas became a character at times savior, at times destroyer, always mysterious. In concert halls, composers set its trajectory to sound. Orchestras performed new symphonies inspired by its speed and silence, movements swelling like gravitational wells, then fading into stillness as though vanishing back into the void. Electronic artists sampled radio noise from observatories, layering it into haunting rhythms that pulsed like signals from beyond. To listen was to feel both awe and dread, as though one might hear the universe breathing. In cinema, directors rushed scripts into production. Some imagined Atlas as a vessel of alien origin, cloaked in stone, arriving as a test of humanity's readiness. Others depicted catastrophe, impact scenarios where Earth's governments faltered, unity failed, and survival demanded impossible choices. Independent filmmakers took quieter routes, portraying lovers staring at the night sky, knowing their lives were framed by the passage of a cosmic visitor who would never return. Writers, too, wove Atlas into poems and novels. Metaphors abounded. It was a wandering exile, a seed cast from a dying star, a mirror to humanity's own restlessness. For some, it became a symbol of transience, of how even stone and ice are fleeting against eternity. For others, it was permanence itself, the reminder that while civilizations rise and fall, the cosmos endures, indifferent. Religious art reimagined it as a celestial sign. Stained glass in small chapels depicted its arc across the heavens. Sermons framed its path as divine punctuation. Mystics wrote treatises, declaring it a messenger from forgotten realms. Painters etched canvases with strokes of flame and shadow, trying to capture not its physical form too faint, too distant, but its psychological weight, the feeling of a visitor glimpsed only once in all of history. Even commerce played its part. Jewelry crafted in comet shapes bore the name Atlas. Fashion shows embraced motifs of silver and black, models moving like fragments tumbling through space. Online marketplaces sold meteoritic trinkets branded with its image, though none bore any true relation to the interstellar body. Humanity, restless in meaning-making, turned even a cosmic fragment into an object of trade and desire. For anthropologists, this cultural wave became as worthy of study as the object itself. They noted how, across continents, people projected hopes and fears onto Atlas, transforming it from a scientific anomaly into a shared myth. It was the same instinct that once saw comets as omens, eclipses as warnings, meteors as portents. The old human reflex persisted. When the sky changes, meaning must be made. And so, Atlas drifted not only through the solar system, but through human imagination. It was at once rock, symbol, prophecy, and song. Its orbit intersected not only with the sun's pull, but with the inner gravity of human minds. And in that intersection, something rare occurred. Science and myth, data and dream, braided together once more, as they had in every age when the heavens sent a sign. But as cultural waves crested, scientists quietly wrestled with a question far heavier than symbolism. What if the odds were wrong? Even if small, even if buried in decimal places, the chance of Atlas brushing Earth could not be dismissed. And so, in parallel with public fascination, the machinery of planetary defense creaked into motion. The first step was modeling impact scenarios. Supercomputers churned through billions of possibilities, altering Atlas's size, mass, velocity, composition each run, painting a different future on digital Earth. Some paths grazed harmlessly, a cosmic near miss. Others struck oceans, raising tsunamis that would dwarf history's greatest floods. A few plunged into continents, vaporizing cities, turning skies to ash. Each simulation was a reminder. Humanity was no longer dealing in the abstract. This was not theory, but rehearsal. Defense agencies studied deflection concepts. Could a kinetic impactor, a high-speed spacecraft, nudge Atlas just enough to alter its path? The principle was proven by NASA's DART mission, which had shifted the orbit of a small asteroid in 2022. But Atlas was bigger, faster, and far less predictable. Timing was critical. A nudge applied early could save the world, but too late, and it would be futile. Nuclear options were dusted off from old Cold War vaults. Documents long shelved resurfaced in classified meetings. The idea was crude but simple. Detonate a nuclear device near the object, not to destroy it, but to vaporize part of its surface, using the blast as a jet of thrust. Scientists grimaced at the thought, uncertain in effect, devastating in risk, but politicians demanded contingencies. Meanwhile, alternative visions surfaced. Could a swarm of smaller drones blanket the object with reflective material, using solar radiation to push it aside? Could laser arrays, stationed on Earth or orbit, focus beams long enough to alter its course? Each proposal carried the same urgency, the need to act within years, not decades. Atlas would not linger. And still, for every plan, uncertainties multiplied. Its exact mass remained unknown. Its structural integrity, solid or rubble, could mean the difference between deflection and fragmentation. Strike it wrong, and humanity might not prevent impact at all, but multiply the threat into countless fiery shards. In this, planetary defense was not only science, but gambling, rolling dice against probabilities measured in the lives of billions. The debates spilled beyond science into politics. Should nations invest billions to prepare for a strike that might never come? Could resources be justified when poverty, climate, and conflict already strained budgets? Yet the counter-argument was simple. If the unlikely became reality, no other investment would matter. Thus, defense was not just about rockets and warheads, but about trust. Would nations coordinate, or would each prepare alone, hedging secrets against rivals? Would humanity face the cosmos as one, or fracture under its oldest divisions? Atlas, silent and distant, forced the question without speaking. And so, in the war rooms and laboratories, humanity rehearsed for an event it prayed would never come. The visitor from the stars had become a mirror of fragility, forcing us to confront the thinness of the line between security and ruin. Even if it passed harmlessly, the shadow it cast had already changed us. As planetary defense simulations filled screens with glowing arcs of destruction and salvation, another layer of discussion unfolded, not in laboratories or military bunkers, but in the quiet corners of philosophy. Atlas, indifferent and passing, was more than a threat. It was a question etched across the sky. What does it mean to exist in a universe that can erase us without notice? Philosophers of science revived the old debates about cosmic fatalism. Some argued that humanity's newfound awareness of interstellar objects revealed the fragility of existence, that no matter how advanced our civilizations, a stray wanderer from beyond could undo us in an instant. They spoke of Atlas as a reminder of our mortality on a planetary scale, a memento mori written not on tombstones but in orbital paths. Others saw it differently. If the universe could destroy us, then our resilience, our attempts to calculate, predict, and prepare were acts of defiance. The very existence of planetary defense projects proved that humanity was no longer content to be passive before fate. In building models, in dreaming of spacecraft, in cooperating across borders, even imperfectly, we showed that we had begun to see ourselves as stewards of Earth, not just tenants. Religious voices entered the discourse. Some framed Atlas as a test of humility. Would we accept that not all forces could be controlled, that existence itself was a gift held on fragile terms? Others, more optimistic, claimed that the very fact of discovery that we noticed Atlas, that we could measure its orbit, predict its motion, was evidence of humanity's growing alignment with the cosmic order. At universities, lectures filled with students eager to discuss not impact probabilities, but meaning. Was humanity unique in noticing such threats? Or would alien civilizations elsewhere in the galaxy grapple with the same? Did Atlas drift through countless skies unseen before it reached ours? If so, were we now part of a lineage of species who had looked up in wonder or perhaps fear? The existentialists found resonance. Atlas was absurd. They argued an indifferent fragment of rock turned into the center of global anxiety. Its lack of intent highlighted the gulf between human meaning-making and cosmic silence. Yet in that absurdity, they said, lay freedom, the chance to choose what story we tell about it, whether doom, unity, or resilience. For the ordinary citizen gazing at news feeds, these questions seeped quietly into daily thought. People wondered about their smallness, about the legacy of their lives measured against an object older than civilization itself. Couples walked out at night, pointing at the same stars their ancestors once did, but now with a new awareness that among them drifted bodies not of our system, not of our story, yet now woven into it. And in this way, Atlas became more than a passing danger. It became a philosopher's stone, pressing humanity to weigh its own existence against the backdrop of eternity. Whether it struck or passed harmlessly, the imprint it left was deeper than crater or scar. It forced us to ask, in a universe that can erase us, how shall we live? While philosophers dwelt on questions of fate, another current moved through the scientific community with quiet urgency. Origins. Where had Atlas come from? What stellar nursery had shaped its atoms? What forgotten system had flung it into the interstellar dark? To trace its path was to attempt the impossible rewinding billions of years of galactic motion, but the effort itself became a kind of pilgrimage. Astronomers fed its orbital parameters into simulations of the Milky Way's stellar dynamics. They mapped backward, letting gravity run in reverse, tracing Atlas beyond the sun's pull, beyond the Oort cloud, back into the broader tide of galactic drift. What emerged was not a single line, but a web of possibilities, threads unraveling across the arms of the galaxy. Each star it might have passed near, each cluster it could have grazed, was like a faint fingerprint of origin. Some models suggested it had been born near a red dwarf system, ejected by the violence of planetary migration. Others hinted at a more ancient source, perhaps a dying star whose collapse had scattered debris across light years. The truth remained uncertain, but the speculation itself was revelatory. Atlas was not merely foreign, it was ancestral. Its matter carried isotopes, mineral ratios, chemical scars that spoke of environments long gone, of fires lit under alien suns. To study it was to read a page from another star's autobiography. Spectroscopy offered whispers. Absorption lines hinted at carbon compounds, silicates, perhaps exotic ices. Ratios did not match those typical of comets in our system. Something in Atlas's signature suggested it had been forged under different pressures, different metallicities, different cosmic weather. It was like tasting water and knowing it came from a faraway spring familiar, yet unmistakably other. This idea electrified the scientific imagination. Here was a relic of galactic history delivered freely to our doorstep, older than humanity, older than Earth itself. To hold even dust from Atlas was to hold a time capsule of creation, a messenger carrying secrets of how planets are born elsewhere. If our solar system was one story, Atlas was proof there were countless others, still unfolding, still scattering their fragments into the dark. And yet, even as models grew more precise, a strange humility accompanied them. The galaxy was too vast, its motions too entangled, to ever trace Atlas with certainty to one single star. Its true home would remain a mystery, just as its true nature did. Perhaps that was fitting. Perhaps Atlas was not meant to be solved entirely, but to remind us that we too are fragments drifting through time, born of forces we barely understand. For scientists, this was enough. To glimpse even the shadow of its origin was to expand the boundaries of human imagination. To know that Atlas had crossed light years to brush our sky was to remember that the galaxy is alive with motion, that the void is not empty but filled with travelers unseen. Its presence confirmed what theory had long claimed. We are not isolated, but immersed in a river of wandering worlds. The more scientists speculated about Atlas's birthplace, the more another thought intruded, a thought that blurred the line between astronomy and myth. What if we were not its first witnesses? Humanity had only recently gained the tools to notice such visitors, but the galaxy is ancient, and Atlas is older than any civilization on Earth. What other skies had it crossed? What other beings, if any, had looked upon its faint shimmer and wondered as we do? Astrobiologists pondered the possibility. If life exists elsewhere, then civilizations scattered across the Milky Way might also have tracked such wanderers. Perhaps Atlas had once passed a star encircled by inhabited worlds, its pale light inscribed into alien charts. Perhaps songs had been composed under its passing, just as humans now painted and wrote. In this way, Atlas became a bridge not between planets, but between imaginations separated by light years. Some went further. They asked whether Atlas might carry not only the memory of other stars, but the touch of other hands. Had some civilization, long vanished, marked it, studied it, even altered it? The lack of clear cometary activity, the subtle anomalies in its trajectory, were these mere quirks of physics, or the fingerprints of intention? Though evidence was thin, the question refused to die. For in wondering, humans glimpsed the enormity of the possibility that we were not the only eyes ever to wonder about Atlas. Historians joined the conversation. They noted how every age of humanity had woven the unknown sky into its myths. The ancients had called comets swords of the gods, omens of war, messengers of fate. In our era, we call them interstellar debris, objects of study. Yet the instinct is the same: to search the heavens for meaning, to project into the void our fear and hope. Atlas, they said, had stepped into the oldest role of all, a cosmic stranger that forces us to ask who we are. Even in indigenous traditions, echoes were found, stories of stars that wander, of fragments that do not belong to any known constellation, resurfaced in light of Atlas. While not literal observations, they resonated with the metaphor, the idea that the universe occasionally sends a traveler across our sky, a reminder that we are part of a larger journey. For the public, these musings stirred a quiet awe. Children asked whether aliens might be looking at Atlas now, from another system, wondering if we existed. Poets asked if the rock carried not just dust, but witness that every gaze it had ever passed under was somehow imprinted upon it, turning it into a silent archive of wonder across the galaxy. And in this way, the interstellar fragment became something larger, not just a threat, not just a mystery, but a symbol of connection. If life elsewhere exists, then Atlas is one of the few things we share, a common messenger drifting through worlds unknown. And if we are alone, then it is still a reminder that the universe is vast, that we are children under its roof, and that to imagine others gazing skyward as we do is itself an act of kinship. Yet, as humanity reached for myth and kinship, the scientific narrative grew darker. For while most simulations predicted Atlas would pass harmlessly, a fraction of probabilities still whispered of impact. These whispers were enough to seed what some called the nightmare model scenarios, not just of local destruction, but of global consequence. Planetary defense planners revisited Earth's history of impacts, from the Chicxulub event that ended the reign of dinosaurs to smaller strikes that scarred Siberia and Arizona. If Atlas were large enough, its arrival could unleash forces far beyond the imagination of policy briefings. Tsunamis racing across oceans, firestorms igniting forests, shockwaves flattening continents, dust veils blotting out sunlight for years. Even the most cautious scientists admitted, should the worst case unfold, humanity would face not disaster, but collapse. What unsettled most was the speed. Unlike an asteroid catalogued decades in advance, Atlas was discovered late, identified only after it had already entered the solar system. Preparation time was measured not in centuries, but in years. Technologies still in infancy would need to mature instantly. International coordination, always fragile, would need to function flawlessly. The simulations were not merely academic, they were rehearsal scripts for the most desperate theatre humanity could ever stage. And still, uncertainty loomed. Atlas might be solid stone, impervious to impactors, or it might be a rubble pile, fracturing into countless fragments under the force of any deflection attempt. In some models, a misguided strike left Earth, facing not one object, but thousands, a storm of fire descending across hemispheres. Each outcome was a grim, branching path, where the difference between survival and ruin depended on details science had not yet secured. These nightmare models were not released publicly at first, but leaks found their way to journalists, and soon the words "extinction level" began to appear in headlines. Panic rose again, not just of impact, but of secrecy that governments might conceal the truth until it was too late. Conspiracy theories flourished, claiming bunkers were being built, that only the powerful would be saved. The very act of studying catastrophe threatened to become a catastrophe of trust. Yet for scientists, silence was not an option. To map out worst cases was not to surrender to fear, but to prepare. If Atlas did pass harmlessly, the work would not be wasted. The next visitor might not be so merciful. And in preparing for the worst, humanity was not indulging dread, but practicing resilience. In the end, the nightmare models were less prophecy than mirror. They showed humanity the fragility of its systems, the arrogance of assuming permanence, the delicate balance upon which civilization rests. And they forced a sobering truth, that even in an age of satellites, rockets, and global networks, a fragment from another star could still remind us of our vulnerability. The nightmare models spread like a shadow, but alongside them, another vision emerged, one not of destruction, but of rebirth. For if Atlas carried the power to end, it also carried the power to awaken. Many thinkers, scientists and philosophers alike, began to describe it not as a threat alone, but as a catalyst for transformation. Writers compared it to the Black Death of the Middle Ages, which, though catastrophic, reshaped societies, economies, and knowledge in ways that ultimately propelled humanity forward. Others invoked the space race of the 20th century, born from fear of rivalry but culminating in the moon landing, a moment of collective wonder. Perhaps, they argued, Atlas was another such spark, the universe's way of forcing humanity to accelerate, to grow, to confront its own limitations before they proved fatal. Some seized upon the idea of planetary consciousness. For the first time, billions were aware of a single object together, watching the same sky, bound by the same fate. The object was a reminder that Earth itself is fragile, a single oasis in the void. If fear of Atlas spurred new cooperation, if it made nations share data and technology, if it drew resources into planetary defense and space exploration, then it might prove to be the unlikely teacher humanity needed. Already, the effects rippled. Budgets once locked in debate were approved with speed. Collaborations once mired in bureaucracy gained urgency. Young students turned toward astronomy, engineering, philosophy, inspired by the thought that their generation might be the one to either save the Earth or redefine humanity's role in the cosmos. Atlas was not only a stone from the stars, it was a summons. Cultural voices echoed this vision. Artists painted it not as a harbinger of death, but as a torch blazing through the heavens, lighting a path forward. Religious leaders shifted tone, some framing it less as punishment and more as opportunity, an invitation to humility, to stewardship, to rediscovering unity. Even in the halls of government, where paranoia lingered, a cautious optimism began to rise, that preparing for Atlas was also preparing for a new chapter in civilization. Yet transformation carried its own risks. Just as fear could fracture, hope could inflate into illusion. Some believed Atlas would pass harmlessly no matter what, ordained as a cosmic lesson rather than a threat. Others argued it would usher in contact with alien civilizations, projecting destiny onto its orbit. For scientists, such hopes were no less dangerous than despair. But they acknowledged the paradox. Humanity needed both the realism of science and the fire of imagination to confront the unknown. Thus Atlas stood suspended between two myths, the destroyer and the redeemer. And in that tension, humanity revealed itself, fearful yet resilient, fragile yet defiant, anxious yet endlessly capable of dreaming. Whether it left us scarred or stronger, Atlas had already transformed us, binding us more tightly to the cosmos, to each other, and to the unyielding truth that our survival depends on learning to live not against the universe, but with it. As the world oscillated between dread and hope, another truth emerged from the fabric of data. Atlas was not unique. If two interstellar visitors had been identified within a handful of years, first Oumuamua, then 2I, Borisov, and now 3I, Atlas, then countless others must have passed unseen across millennia. Astronomers realized that interstellar wanderers were not rare at all. Humanity had simply lacked the eyes to notice them. This realization reframed everything. Atlas was not an exception but a herald, proof that the galaxy constantly trades fragments between its stars. Each planetary system is not a sealed chamber, but a leaky vessel, scattering pieces of itself into the dark, gifting them to others. Our solar system, too, must have flung debris into the void, carrying whispers of Earth's birth into alien skies. Somewhere, perhaps, a fragment of our own origin streaks silently past another civilization, puzzling their astronomers as much as Atlas puzzles ours. The implications were staggering. If interstellar objects are common, then so too are opportunities to study them. Perhaps within decades, missions could be launched not in panic, but in preparation, patient probes lying in wait for the next messenger. The science of interstellar visitors could become as routine as comet studies are today. But with that possibility came responsibility, to decide whether humanity would treat these objects only as curiosities or as the first bridges of a galactic dialogue. Some scientists suggested that such wanderers might carry more than inert matter. Within their icy cores could lie organic molecules, complex chemistry forged under alien suns. They might be carriers of seeds, sprinkling prebiotic dust across worlds, igniting life where conditions allowed. Panspermia, once fringe speculation, gained new gravity. If Earth's life was born from such seeds, then Atlas was not just a threat or a teacher, but a cousin, a messenger, bearing family resemblance across light years. For policymakers, The realization was sobering. Atlas would not be the last visitor to stir fear. Others would come, some harmless, some perhaps less so. Planetary defense was no longer a luxury, but a permanent necessity. The night sky was not static, not safe. It was alive, filled with trajectories intersecting ours. To ignore that was to remain provincial, vulnerable to cosmic chance. Philosophically, the shift was profound. Humanity had long imagined itself bound to one solar system, its fate local, its threats internal. Atlas revealed otherwise. We live in an open galaxy, a river of stars and stones, where boundaries are porous and histories collide. To exist here is to accept that we are participants in something vast, a cosmic exchange stretching across billions of years. And so, even as Atlas continued its arc toward departure, its legacy deepened. It was not only itself, but the countless unseen companions it represented. Each unseen traveler was a reminder that we are part of a galactic community, not of civilizations perhaps, but of matter, of trajectories, of shared origins. The fear of Atlas began, slowly, to transform into perspective. It was not the herald of an ending, but a window into continuity. The universe had always been in motion, always exchanging, always scattering. Atlas had simply lifted the veil, reminding us that we drift together in a galaxy of endless travelers, all bound by the same gravity of time. As the recognition spread that Atlas was only one of countless interstellar visitors, attention turned to what lay beyond its physical presence, the long-term legacy it would leave behind. The object itself would soon vanish into the dark, but its imprint on human civilization had already begun to take shape. Space agencies drafted new protocols, no longer content with reactive observation. Plans were drawn for interstellar watchtowers, networks of next-generation telescopes designed specifically to detect wanderers long before they neared Earth. These instruments would be tuned to faint glimmers on the cosmic horizon, catching objects years or even decades earlier, allowing time not only for study, but for missions of rendezvous. Humanity's relationship to such visitors would shift from surprise to expectation. Universities established new disciplines, departments of interstellar object studies, weaving astronomy with geology, chemistry, and planetary defense. Students no longer studied comets as relics of our solar system alone, but as members of a galactic diaspora, each fragment carrying its own unique fingerprint of a different stellar origin. Curricula expanded, lectures reframed. The universe was no longer an abstract concept of distant stars, but a dynamic environment that regularly touched us with physical evidence of other worlds. Policymakers, too, felt the shift. International treaties began to discuss planetary hazard response in the same breath as climate agreements, recognizing that safeguarding Earth extended beyond atmosphere and oceans. The idea of a planetary identity, Earth, as one polity under the shared sky, moved from philosophy into tentative frameworks. Atlas, indifferent though it was, had forced the first conversations of a truly planetary government. For artists and storytellers, Atlas remained inexhaustible. Even after it faded from the sky, its story lingered in novels, films, and poems. It became a cultural archetype, the fleeting stranger, the messenger of both dread and wonder, the mirror in which humanity glimpsed its fragility and its resilience. In centuries to come, children would read myths not only of comets and eclipses, but of the interstellar visitor that once turned the whole Earth's gaze upward. In quieter moments, though, its most profound legacy lay in perspective. Millions of ordinary people who had never before considered the scale of the cosmos had looked up and realized the universe was not silent. That realization changed how some lived their lives. Farmers planting seeds thought of cosmic wanderers carrying seeds of their own. sailors at sea compared their passage to Atlas's drift across the void. Lovers under night skies felt the intimacy of knowing that, for a fleeting time, they shared their lives with a visitor born around another star. Thus, Atlas's true mark was not only scientific, not only political, it was existential. It reminded humanity that we live in a galaxy that is porous, alive, unpredictable, that our fate is tied not only to ourselves, but to the restless river of matter that flows between the stars, and that sometimes the most lasting changes are not caused by impact, but by encounter, by the brief, shimmering presence of something that makes us see ourselves anew. As Atlas neared its closest approach to the Sun, the world held its breath. Instruments across Earth and in orbit turned toward it, hungry for final clarity. If there were hidden outgassing jets, they would flare most clearly now. If its surface held exotic ices or metals, the Sun's heat would reveal them. For astronomers, it was the climax of the encounter, the moment when secrets long veiled might finally be unveiled. Solar observatories, designed to study our star, joined the vigil. The Solar and Heliospheric Observatory, the Parker Solar Probe, even the aging SOHO spacecraft caught glimpses of Atlas against the searing backdrop of the Sunday. Filters strained, algorithms extracted its faint trace from the solar storm of photons. In those images, scientists searched for signs of sublimation, for plumes of dust that would betray a comet's heart. Yet Atlas remained ambiguous, neither wholly silent nor clearly active. It whispered when all had expected it to sing. The tension was mirrored on Earth. News outlets framed the perihelion as a moment of decision, some even dramatizing it as a trial by fire. Would Atlas break apart, scattering fragments like icing before it? Or would it endure, stone strong, its integrity confirming its alien resilience? Speculation ran wild, with each new image dissected by scientists and enthusiasts alike. For those watching through telescopes, there was a sense of intimacy. Here was a body that had traveled for millions of years, through interstellar frost and galactic night, now passing within reach of our light, brushing the furnace of our Sunday. It was as though Atlas had entered the hearth of our system, daring the fire, leaving us to wonder whether it would emerge altered or whole. Some scientists saw in this moment an analogy to humanity itself. Like Atlas, we wander through uncertainties, tested by the heat of crises, uncertain whether we will fracture or endure. Its passage near the Sun was a metaphor made real, an ancient traveler tested by light, just as civilizations are tested by history. When the data came, it was maddeningly inconclusive. Atlas brightened slightly, suggesting activity, but no dramatic fragmentation was seen. Spectra hinted at faint carbon chains, possible volatiles, yet the signals were weak, elusive. In truth, the Sun had not burned away Atlas's mystery. It had deepened it. For philosophers, that was the greater lesson. Not all encounters yield answers. Some intensify the question. Atlas remained itself, part comet, part asteroid, part enigma. It reminded humanity that the cosmos is not obliged to reveal its truths in the clarity we desire. Sometimes the gift is not certainty, but humility, the reminder that mystery endures even under the brightest light. And so, as Atlas turned from the Sun, beginning its outward arc, humanity was left with more riddles than resolutions. Yet the world did not despair. For the act of watching together, of waiting through that perilous passage, had bound us more closely to one another and to the cosmos itself. As Atlas receded from the Sun and began its long outward drift, the tempo of observation changed. No longer framed as imminent peril, it became a fading signal fainter by the week, retreating into the night. The telescopes strained harder, exposures lengthened, yet still its light dwindled. Soon, it would pass beyond the grasp of even our greatest instruments, returning to the anonymity of the galactic tide. Humanity had only months left to witness it. This twilight phase carried its own kind of poignancy. Scientists rushed to complete final measurements, knowing every photon mattered. Long baseline observatories gathered parallax data to refine its trajectory. Spectrographs searched for the faintest trace of unusual chemistry. Radar stations, though stretched to their limits, attempted last echoes, as if waving farewell with pulses of radio. Data archives swelled, filled with terabytes that would be studied long after the object itself was gone. Yet even as its physical presence waned, its symbolic presence deepened. Public attention lingered, not with panic now, but with reflection. Documentaries aired, charting the saga of discovery and debate. Schools held farewell nights, where children peered through amateur telescopes, glimpsing the faint streak of light that had captured the world's imagination. In cities, artists projected its path onto building facades, a luminous arc reminding citizens that they had lived through a rare moment when the whole planet looked skyward together. In science, Atlas left behind paradox. It had revealed enough to transform our view of the galaxy, proof of countless interstellar visitors, hints of strange composition, questions of planetary defense, yet withheld enough to keep mystery alive. Its identity remained unsettled, forever suspended between categories. Not comet, not asteroid, not wholly natural, not convincingly artificial. It had slipped through our definitions, just as it slipped through our solar system. For some, that was frustrating. For others, liberating. Mystery, after all, fuels science as much as resolution. Atlas ensured that curiosity would not fade, that future generations would continue searching for the next visitor, more determined and more prepared. In its silence, it had sparked a fire that no distance could extinguish. And so, as its glow dimmed to near invisibility, the narrative shifted from urgency to elegy. Humanity had not mastered Atlas, had not unraveled all its secrets, but it had borne witness. For a fleeting time, a fragment from another sun had crossed our sky, and we had chosen not to ignore it. We had measured, debated, dreamed, and feared. We had seen ourselves reflected in its path. The fading of Atlas was not an ending, but a handoff to the next object, the next discovery, the next challenge. Its true legacy was not the data alone, but the way it had changed humanity's gaze. Once, we looked at the night sky and saw only stars. Now, we saw travelers among them. And in that recognition lay the first step of a larger journey, one that will not end when Atlas vanishes, but will continue as long as humanity dares to look upward. And then came the silence. Atlas, once bright enough to command nightly vigils, slipped below thresholds of detection. Observatories reported its faintest whispers, then nothing. The interstellar visitor had come and gone, leaving behind no crater, no scar, only memory. Its orbit carried it outward, past the planets, into the Black Sea from which it came. For millions of years it would drift unseen again, perhaps never to encounter another civilization at all. On Earth, the absence was palpable. Scientists closed observation campaigns, their final datasets sealed like time capsules. Conferences shifted from current monitoring to legacy analysis. The urgency that had gripped governments softened into longer, slower debates. Budgets that had ballooned under the shadow of Atlas were now reshaped into future-facing initiatives. The visitor itself was gone, but its echo remained in policy, in technology, in thought. For the public, the end was quieter. Headlines faded, hashtags cooled, yet something lingered in collective memory. People who had once stood on balconies or hillsides to glimpse Atlas still recalled those nights, when for a brief time they felt part of a larger story. Children, who had drawn its path in classrooms, carried the image into their futures. Artists continued to depict it, writers continued to imagine it. Atlas had vanished, but in human imagination it had become permanent. Philosophers closed the chapter with reflection. They noted how Atlas had revealed two truths at once: the fragility of life in a universe of wandering giants, and the resilience of a species that could notice, measure, and prepare. It had been a mirror showing us both our fear and our capacity to unite, however briefly. Its silence now was not emptiness, but reminder that the universe is always larger than our certainties, that mystery does not disappear when it passes from view. And so humanity entered the aftermath, changed in subtle ways. A planet that had once thought itself isolated now knew it lived in a galaxy of encounters. A civilization that had once ignored the sky now watched with greater vigilance. A people who had once looked upward for omens now looked upward for answers. Atlas was gone, but it had left behind questions that would outlive its trail. What else drifts between the stars? Which will come next? And are we too destined to wander, fragments of Earth one day carried across alien skies? The story ended not with certainty, but with openness, a door left ajar to the cosmos, an invitation unspoken yet undeniable. For in losing Atlas to the dark, humanity gained something greater: the knowledge that it is not alone in motion, that the universe is restless, and that every visitor, no matter how brief, carries the reminder that we are part of that vast, unending journey. Now the night is quiet again. The telescopes have turned elsewhere. The headlines moved on, but in the stillness of the sky, the story of Atlas lingers, like an afterglow that refuses to fade. You may step outside, lift your gaze, and see only familiar constellations, but you know now that unseen travelers pass among them, silent, ancient, unknowable. Imagine the path of Atlas still unfolding in the dark, a faint stone gliding past lonely stars, its surface etched with memories of suns we will never see. Imagine how small Earth must already seem to it, shrinking behind into a pale blue dot, then into nothing at all. And yet, for a moment, we mattered. For a moment, its journey and ours intersected, and the encounter changed us. Breathe slowly now. Let your thoughts drift as Atlas drifts unhurried, carried by forces larger than will or choice. The visitor's story is not of endings, but of continuities, the continuity of motion, of curiosity, of wonder. Even as it recedes into silence, its legacy grows louder within us, reminding us to prepare, to dream, to watch the skies with humility and with courage. Close your eyes and let that thought rest with you, that we are not fixed, not static, but wanderers too, bound to a planet that sails its own orbit through the dark. That every night above us is alive, every silence full of motion, every horizon waiting. The story of Atlas fades, but the night remains, vast and gentle. In its quiet, let yourself find calm. The universe is wide, but it is not empty. We are here, together, part of its endless unfolding. Sleep well. Sweet dreams.